morning or good whatever it is. He said at 12. Um, House cleaning, vacation, get control, blah. So yesterday, let's get that. I need to work on that pre-roll thing. It's. I like the basics, but it needs, yeah, and this beard. Take it off. Actually, you can go to my Patreon, get the Beardmaster membership, and just tell me what to do. I mean, simple as that. But you don't have to. It's just for fun. So yesterday, let's get out of the picture. And actually, okay, are we clean? Oh yeah, yesterday, last second hacking with the model view projection matrix. So basically, we started to add. We used the textured shader. We started to support the model view rotation matrix, right? And wondering, brain farts to get going. I mean, that's the optimum, right? That's how you do it. Thanks for the follow, Davey. Davey? I think I did that rightish. So we added the model view projection matrix, and then I ran out of time, so we hacked in the setting of the model view projection matrix. And right now, all that is, it's a unit matrix, unit identity matrix. So the ones in the diagonal mean it stays the same. So if I run it now, all the textured stuff is still textured correctly. So that's and positioned correctly. So that's nice. And let's just double the X value here in the identity. We have no way to set that yet. So what we can do, so the scaling works. So you see the best with the mouse cursor, because this is the center and it moves by like double the speed in the X direction, while Y is still okay. So the matrix is passed incorrectly and applied correctly. Oh, we might still have it flipped upside. So there's always a discussion: row order or column order for matrices, and we don't know if we did it right or wrong. So there's only one way to find out, and I actually want to set the model view projection matrix to match the viewport. So right now, where were we? In the app, we basically assume the screen is in normalized device coordinates, right? So -1 to 1 and -1 to 1, but actually you want something that's closer to pixels, because that's so much easier to handle. I mean, if I place a UI element, do I want to place it at 0.85731, or do I want to place it at 40 pixels from the top? So that would be nice, but for that, step one is actually, how do we do this? So I make this okay, so slow down. We're still in the add support for MVP uniform, right? That's still work in progress. But right now the material basically uses its MVP matrix, and that's just initialized up here. So it's set to identity, and then it stays identity. So obviously we want to be able to set that. And that we do, question mark. Do we want to set, how do we want to do that? Because We're still doing the Fiish port, so we could just do it like Fiish did. And actually... Oh, it's MVP matrix, right? So we set it on the render effect when we bind the render effect, but actually that's not needed, right? So that's interesting. I mean, we only set the MVP once per frame, right? So we could just this is V0 of the Rust version of this framework, right? So let's not overthink stuff, but try to move them in the right direction. So in the end frame, right? Here is where we render stuff. Oh, actually we already, I mean, that's actually good. We already hooked. We have one model view projection matrix, right? So what we need is, and I'm wondering where I put this, probably down here. We need to have a path function set MVP matrix. Yes, short names in this case is fine if it's something that's so well defined, and this basically says self.mvp equals, and we have to deref here. So that's the setter. So basically, instead of using our own, we use the global one here, right? So if I run this again, nothing will change. Well, all materials used it, but all materials are still using the identity matrix, right? Oh, what's it called here? It's actually called MVP matrix, and that might be the better name here, which I fully agree with. I mean, we set the MVP matrix, so better have the MVP matrix, right? And we need this for scaling, rotation, and technically for projection as well. So the P is for projection. How is a three-dimensional cube that we render and basically map to the screen, so closer stuff is bigger, and further away stuff is smaller. Since this is a 2D game, we don't care. And actually, it's Matrix 4.4. And Matrix 4.4 doesn't have a copy, right? Matrix 4.4 doesn't have a copy. So we're reaching the end of all the boilerplate stuff. I mean, I'm still wondering if I want to do animated textures before. Yeah, we don't have a copy before we get too deep into game code. I'm going to do 2 hours now, then have a 2-hour break, then do another 2 hours, and then have another 2. So I'm going to split this day a bit. It's nice and sunny, and it's my vacation. So just if you don't like it, copy clone is fine. Well, do we need? Copy is fine. It's just 16 floats, so who cares? It's just a mem copy. And my neighbors have that stupidly annoying, loud singamaboo on again. Let me close the door real quick. So this is still working, obviously. Obviously, this is not very helpful. Well, it is, because now we only have one MVP in the renderer. And maybe we do the orthographic projection, right? So maybe at the beginning of the frame, so the very first thing we do in the renderer, right? So renderer begin frame, and it doesn't matter if we do it before or after cleaning, but basically renderer think we called it set. I want to stick close to the names. So so we have a set MVP matrix ortho. Set MVP matrix ortho is fine, right? And that usually is left, right, bottom, top, flow, top, near, far, right? So let's actually say, okay, let left equals -1, let right equal. Let's just replicate what we have right now, right? Let top equals, and I'm not even sure if top is minus or plus. So top is plus, because the textures are coordinate spaces. Top is plus, let bottom equal -1. So this defines our sides and tops of the cube, and now we need the near and far. And actually, the near and far are a bit more complex, so I want to check what we used the last time. Well, basically, near and far used to be, oh, it's also 1 and 1. Okay, so let near equal, and order here is important. Near is positive, so this is negative z. Welcome to pain later, but so this is our cube, right? And then we just say, and I'm gonna group them, so we say left, right. Is it top bottom or bottom top? It's bottom top actually, which is interesting. Not sure why I bottom top, and then it's near far, right? So this would set, I actually like this. This would set the projection that we currently have, right? So if we implement that and actually implement that correctly, we expect no change, right? So let's go into the renderer. And actually, where do we do it? Setup is begin frame, end frame, clear. I think it's somewhere here. So we have a pop function, set MVP matrix ortho, gets a mutable self, it gets left f32, right f32, bottom f32, top f32, near f32, and far f32, and it does some magic on the... I wonder if you actually want to put that on the matrix. Maybe we do this differently. I mean, maybe this is a matrix function, right? We have identity, and identity is nice, but maybe we want to orthogonal projection. So basically we have two steps, right? And that's just for let MVP equal matrix 4 ortho. And then we have all the stuff here. Yeah, then we can manipulate it. That's and then we just say, okay, then we just have the setter here. That just gets a reference. We could do it in place, but again, I'm not worried about these copies. So basically, let's fix up the renderer. So this just gets the matrix, right? So this is just MVP matrix 4. I can So that sets the MVP, right? That just says self.mvp matrix equals MVP. Let's actually call this matrix 2, right? So this says now use it. So I could just say let MVP equal matrix 4 identity, right? So this would be the old behavior, but we have control now. I hope. I shouldn't have done that pixel thing yesterday, but it was so much fun. Cost us like 2 hours, and these 2 hours we're trying to make up now. But this is not a race. Hmm. Oh, obviously we have to say use mass. If you use it, you have to use it. Don't quote me on that, please don't. Don't quote me on that one. I'm not sure why this is... Oh. Ortho. No associated function ortho found in matrix 4 because we didn't save, and actually this needs to return a self. And for now we just cheat, right? We do nothing because I want to check the other pass first. And we need a pretty printer, right? I want a pretty printer for the matrix, because otherwise it will just be an array of stuff. It's hot again, I'm not sure what's going on here. Bad food. Expected 7 arguments, supplied 6. Wait, what? Oh, because this doesn't get a self. This is a creator, right? Ding, 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 ding. I need to take out my keyboard so I can... No, we had that. We don't want to do that. You don't want me to entertain you with my music while Rust is building. You don't want that. And next thing is I'll be singing you songs, right? Yeah, and then dance. At least want to get the projection stuff out of the way and the viewport set up correctly. So that's still working, and this is the ugly print I'm talking about, right? So let's do a... let's actually steal a debug printer from here and add that to the matrix. I never know the exact syntax, so I either copy it or... So we remove the debug trait here. We remove the derived debug trait here, so... And actually what I want is a new line. And then 4 values, right? To be formatted, and then a new line, and I want that 4 times, right? Maybe I want to do a loop. Maybe we do it. Let mute r equal actually this plus the new line plus nothing, and then say for E for element in for I in 0 to self.m.length. You could just enumerate, yes, true, let E equal I self.m/I. We could just enumerate, right? We could just do I comma E and say self.m dot iter dot enumerate. And then we just say R equals R plus. Can I append in this way with the formatter, and I just do I don't care about the trailing white space. Maybe I want leading white space, right? And this will just print E. And then at the end, I just return the result. I'm pretty sure you could do this more idiomatic in Rust with a map or something, but so there's a final new line missing, and I want a new line every 4 items, right? Why is this taking forever? What is it doing? Yes, I'm a klutz. Let's actually not do the optimization. Maybe that's faster. It will run slower, but maybe the compiler is faster. Did you hear that sound? I'm falling apart. I'm pretty sure I heard a screw drop on the floor. Maybe it jumped out of my neck. Oh, for reals. For reals. Oh, just shut up. I'm too lazy for this time in the morning. This was supposed to be a wake up fun, so we do 4. Then we do a new line. And let's not be smart, we do a single format, it's debug 1, 2, 3, 4, and then we just do M0, M1, M2. I'm gonna regret this in a second. And then we do M3. And we copy that 3 times. Yeah, I could have edited downwards. I know. I'll do that just for you. So this is 8, and thinking ahead, 12 for the alignment, 9, 13, 14, 10, 11, and 15, right? I wish that there was a way to give the derived debug some formatting hints, if you get what I mean. Maybe something like for this array, telling it, hey, you know this is an array, but I like to have it in four rows, right? And that's the trailing semicolon here. Because I do this all the time just to get nicer debug formatting, and maybe there's something in it. Maybe we can extend that derivative thingy to... Shall we do that? Not this week, not this week, not this week, not this week. Not this week. Unexpected token. Because we forgot the comma here. I'm not sure what's going on with my system. It's slow like... It is slow. When I did a rough estimation of what we could do in this week, I didn't factor in how slow the builds are, right? I mean, we spent like 50% of the time, and now it's telling me, yes, it's self.m. So what I'm gonna do is let m equal reference to self.m, right? Because I'm not gonna fix that in the this is looking far too nice to splatter it with self. Let's see if our formatting looks anything useful. I mean, probably we need to be more specific with the float formatting, but I mean, what is going on here? This should be like bam. Silence. Okay, so this is a much nicer view of the matrix, right? So this is currently, there's one new line too many somewhere, but I'm not sure about this one. Oh, we do a right line, so this one is too much. But that looks like we can debug it, because usually by eyeballing a matrix, you can say, something is off here. So how do we do this here, right? Technically, what we want here is self m colon. I didn't press that button. I didn't press that button. So we want this, right? Well, this with the right values, and we can just look up. No, if we just jump here, I mean, this is just how you calculate that, right? This is just straight out of the book. So basically, you have the right minus left is a you have the right plus left, which is the total, and the right minus left, which is and then you just so if right minus left is, so our right is 1, our left is -1, so this will be 2. So 2 divided by 2 is, so if our viewport is exactly too wide, I have to try to hit the camera viewport here, too wide, then we have to divide by 2 to make it 1, right? Well, this is a scaling factor, and actually I'm just gonna copy this over to the Rust version as reference. Because this is definitely correct. And then you could do all the calculations inside here, but that makes it totally unreadable. So I just gonna say let right plus left equals right plus left, right? Right plus left, right, yeah. Let right minus left equals right minus left, and then same for top plus. Maybe I'll do an extra video at some point explaining how to derive the orthographic projection, but I haven't done this in like 15 years at least. But basically this is just far fat far plus. There's something wrong in the formatting that's driving me crazy, but let far minus near equals far minus near, right? So this is basically just relations between stuff, and since it's orthographic, there is no perspective, there's no depth division. So this is driving me crazy. So this is just this, right? Right plus left, right minus left, top plus button, top minus button, far plus near, far minus near. And let me just go through. I mean, the first one is just this, right? So this is 2.0 divided by right minus left. And then we have a 0. And then we have a 0. And then basically we have the ratio. So this is right plus left will be 0, right? Divided by 2, divided by right minus left, which will be 2. So this will result in 0 down here. And that's what we want, right? So if we had a viewport that's shifted to one side, that would change. But since we use 1, 1, that doesn't. So we have RPL divided by RML, right? And let's align all of these, because I'm leaning towards aligning the divisions. That might turn out to be a bad idea, but maybe it's more readable. So this is a 0, this is a 0, and if I make this wider, this is a 0 as well. So all we care about is the diagonal and the bottom row, right? And here it just, so the first is right left, it's X. So the second one is actually top minus bottom, that's Y. And then the next one is 0 again, aligning this for readability. And then this one here is basically the same, right? Top minus bottom, so that's a ratio for the shifting side to side. And I'm gonna align this as well and align. Oh, maybe I should have, no. I want this here and this comma here, right? That's what we want. So we see the diagonal visually, at least a little bit, and then we have, this is basically same again for Z. So FMN. And I know how this is gonna pan out, so I'm gonna format this straight away. And this down here is again the same. It's far plus near divided by far minus near, and this one here is important because that's the final division that scales everything, right? So this should be our projection matrix. And maybe we could reformat this, but let's run it, right? Let's just run it. If it ever compiles. Oh, what did we do wrong? TPB. Did we have a typo there? TPB. Where is this? TPB. Line 54. Cannot find TPB. Oh, TPB. Typos for the win. I'm So this is 1111, right? That's what we wanted to see. So if we go into Fiiish app and say, what if we open up the angle, right? We want a wider box. So we actually multiplied by 4, right? Left side from 1 to 2 and right side, well, we doubled it up. We went from 1 to 1 to 2 to 2, so 2 wide to 4 wide. So we expect everything to be squished in X and actually the diagonal to reflect this, and this bottom down here shouldn't matter because we don't have a shift from left to right. And this would be so much easier if it wasn't compiling for forever. This is just changing our coordinate system that we hand in, right? So right now we had it in normalized device coordinates anyway. Oh. Oh. Why is this 111? Oh. Okay. Fair enough. So maybe the test before was already broken. Let's see. I want to know. It's fucking. It's the stupid Firefox thingy that has crashed somewhere again. Just some random tab crashed and my whole system feels like. I'm gonna fix that. Actually, I'm gonna go black while this compiles and have a quick look what's going on. If I could change my screens, actually. Dear Firefox, you're in the frickin' background. And there's no tab open. There's literally, I mean, the configuration tab for my internet connection is open. But there's nothing open. Yes. Well, we'll live with that and probably just do a reboot during the stream, so... Oh. Where did the window go? You probably have it on the other screen somewhere. So this is squished now, and you can see this diagonal now changed to reflect that. Why is this -1? Maybe this -1 is so this squishes our coordinate system by X, right? So if I go back to 1 1 here, then while the compiler is compiling, I want to check something in here, because basically, oh, that's good. So here we do some strange, we have a scaling factor, and basically we pretend the height is always 1024, right? It's still compiling. That is because all the levels and the UI are laid out that way, and then the widths. So we scale the height of the viewport that it matches, that it pretends to be 1024 high, so minus 512 to plus 512. And then the width is just keep the aspect ratio, so you see the mouse cursor is correct. And now we have 1, 1. I'm a bit worried about this minus here, but maybe that is what we want. So we could just say top is 512, right, and bottom is minus 512. So now we have a viewport that's exactly 512 high, right? The problem is, we're rendering everything with the wrong sizes, so we need to fix that. Excuse me. And this is not gonna be fun with, I'm leaning towards killing. Let me, sorry about that. And it's literally stupid Firefox having empty tabs open. And actually, while I close tabs, I can look at Firefox. I wish there was a way to tell Firefox, hey, can you tell me which tab is using so much energy? Come on. It's not this one. I mean, I have quite a bit of the documentation open. Remember that tab was give me a second, we just close all the Rust documentation. That is actually a browser that had. I wish there was a close all other tabs button. Come on. Firefox needs like 20 seconds to close a tab now. I mean, how hard can it be? To write a browser that's not a pile of useless. I mean, it's literally just pre-rendering and then displaying one texture, right? There's no magic in a browser whatsoever. It's just it's a problem that's been solved 30 years ago, and still all browsers are badly implemented. Every single one of them. And yes, please hate me, but all of them are a nightmare implementation. I wanted to work on Mozilla a while back, well, when it was still called. Well, I wanted to work on Phoenix and Firefox, but I looked at the source base and said, look, no way, you created this mess, you fix it. So stop ranting, old man. The kids know what they were doing. Well, they will know what they are doing in 20 years. I'm making a ton of money by creating a very bad product. I mean, no, I will not write your browser from scratch. Oh, maybe. Maybe. I mean, I literally managed to close 5 tabs in the time I've been ranting. How can some tab that's not even active in the foreground, somewhere in the background, have such high priority. I don't get it. So I just hello. And I didn't hit the right one. So let's close this one here, and this one, and this one. Which means I won't see a chat anymore, which is a bit annoying. And I still didn't find it, so it's still not it. I have my email open. Maybe reading your email is not something that's supported in a modern browser. I mean, there's literally nothing running. Okay, I close my email. No, it's not that one. I have an article open that says crappy software kills people, and I probably want to talk to the people who created this crappy software, and maybe let's not go there. So I have literally, okay, sorry about this. I will just, I would love to, okay, I will just close my browser. Close 2 windows with 4 tabs. And Firefox is closed. It's still eating 80% of CPU. I do want to see a chat, so I'm gonna restart this real quick and reset up all my windows here. Yeah, thank you for opening stuff I didn't ask you for. History, oh, and the restore reasons. Restore previous session is so hidden. So literally I have Fiish open on GitHub. I have my Twitch created dashboard open. And I have my local network bandwidth monitoring tab open. And my CPU is at 70%. And for what? Maybe close the Twitch chat. Maybe restart audio? Okay. Step 1, I give you visibility again. I'm gonna get out of the way, and I just closed everything, and Firefox is again just eating everything for having a Twitch chat open. Are you kidding me? That's 5 lines of text, so I mean, I have a 12 core machine and it's eaten up by a stupid. Okay, 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 okay. Let's run this again. So now we have something that's 512 high, and everything that's textured is now using the wrong height. So basically, let's do the cursor. Where is the cursor thingamaboo? So we use this fish at the cursor position, and this is the height, right? This is the size. So let's say we wanted 64 pixels wide. That's why we did this exercise, to be able to talk in pixels, right? And we only did, oh, we did it for the height. So let's make this 64 pixel high, right? I have no idea what's going on. I mean, this seems to be slightly faster. So now our fish is exactly 64 virtual pixels if we assume our screen is 1024, right? So if I make our screen higher, and actually here you see the other fish that have the wrong height, but our virtual screen is always 1024 high, and that's scaled. So let me check file fish data swim. Well, this is a 1128 texture, right? So let's say we fix both. So we want this to be pixel perfect in virtual pixels, right? We could just say, okay, it's 512 by 512, right? This will kill our aspect ratio. This will kill our aspect ratio. But we do open the window, right? We know it's 16 by 9. Oh, give me a second. This slow compiler is not helping me right now. I'm gonna reboot the system during the break later. Maybe just go all the way to 6. I have an appointment at 6 and wanted to get some sunshine, but maybe we don't. So obviously the movement of the fish doesn't work now because we move it by 1 pixel, right? So that needs to be fixed, and the aspect ratio is wrong. So if I fix the test texture, right? So the test texture file dummy data test texture.png, that's 64 by 64, right? So let's say this is 64 by, and this is now in pixels. It's a 2D game, so measuring everything in pixels is a nice idea. So this -1 to 1 coordinate space was a hack from the start, and we knew that. Too much water. And this system is unusable. I'm not sure. So this now has the wrong aspect ratio, right? So if I create a new tab and cd Fiiish and open dummy data test texture 1.png, right? In the hopes I get, so this is square, right? And put it down here. And this clear, well, we can make it square. Can make it square by making the viewport square, right? Something like this. I mean, we are actually in window. No, in window we set the size to full HD, right? We could just say, let's set the size to 512 by 512. So if we set the size to 512 by 512 and run this now our virtual pixels exactly match the screen pixels and aspect ratio, and everything is fine, right? So handling different aspect ratio screens in games is just. So this is now a perfect square, right? You can probably guess this, but that's not how our screen is usually wider than high, right? So what I want is if I scale in this direction, everything gets bigger and smaller, which it does, and if I scale in this direction, I just want to see more on the right and left and right side, right? So this scales in both directions, and this only shows me more, right? So what we need is actually the size. And the size, we somehow need the size, right? So what if the window update context? Yeah, people. So what if the window update context had actually the window size? Makes sense? So what if this actually had the window size as a vector 2? Right? And the default here is window size vector 2 0. So we need to pass through the window size to handle the window resizing. And then in the window, we need to know the window size, right? So in the run, we probably can. Do we can? Do we can? Do we can? Where's the window update context? Basically here we say let window update context dot window size dot x, right? That's the width. So how do we get the width? We have the windowed context. Do we use, is this actually a thing? Window, probably I have to check the gluten Dooku, and that means opening more tabs, which will make my system slower. I think the windowed context gives us a window, right? We have a windowed context, and we can ask the windowed context for the actual window. And the window actually has an inner size, right? Yes, and that's a physical size. So we can get the window, and that has an inner size. So that has an inner size, and that inner size is a physical size, and that has a width. And that width is of type something. But we want it as F32, right? And then we do this, say, well, let is wrong here, sorry. So then we do the same for Y, correct? And that's the height. So the window update context now knows the window dimensions. We're almost done with the boilerplate. We're almost done with all the framework. But I mean, then we're like 15 hours in and have. Oh, inner size is a method. Okay. Probably we should cache this. We should just get inner size into a variable here, but might help readability. Fair enough. Where's the arrow? Yeah, that was not so smart. Something felt odd when I typed that. So now we know the window size, right? We do know the size, and we need to do something with that, which we will in a minute, but okay. So now the Fiiish app can know its size, right? So let's say we know the window. Maybe it's just the size, right? And that's a vector 2. We have to be careful with the size. We as vector 2 0. The transmission of information between the parts is still. So in the update, we have the window update context, right? So in the window update context, what we will do, and we will need the window scaling here in a minute, so I'm gonna do it exactly here. I'm gonna just say self size equals book window size, right? Book dot window size. And then down here, we need to do some scaling, right? We want top bottom to be always 512. So we have a scaling, and that's basically what we did in Fiiish in the C version here, right? So that's basically this. It says if we're higher, we have to scale smaller, and if we're smaller, we have to scale higher. So our scaling is just adjust that. So that's 1024.0 divided by self.size.y, the height, right? And then we need half of that, right? So I just closed that, but we need half of that because we scale the width and the height by that, right? So this is half. So if I say let scaling equals 0.5, just to have it in separate. I'm not sure why I put a space there. So now, if I would scale, if I would say this is self.size.y times scaling, right? And this is minus self.size.y times scaling. And then I would just debug, let's just debug top and bottom, right? Top and bottom. And actually, let's debug the scaling. So basically, this says the height, the virtual height here should always be 512 to minus 512, right? So let's verify that. Because otherwise, we just chase ghosts forever. Ghosts forever. Sounds like a good game name. The Lonely Trip of the Forever Ghost. The Lonely Trip of the Coder Who Couldn't Type. Now you're laughing. That's funny. Okay. We're almost game. Yeah, and I wanted to do a cargo run, but Let's run the check for the run and the run for the check. Almost have the viewport handling right. Almost. So what you see here is the scaling is 1 and the top is 512 and the bottom is 512, right? So if I make this smaller, wait, did we miss something? So window update context, window size. We did update that, right? In the window on every frame. This is outside of the loop. We don't update it. So basically we do this inside the loop. Every frame we just get the current size and that should be fine. We could just change it on the resize event, that's actually true. That is actually true. So this is 512 and we get 512. So if we just make this smaller, so y is 376. So we have a scaling that says, please make it bigger. And this is just rounding error, so that's fine. So if we make it smaller, the scaling factor is positive, and if we actually make it larger, the scaling factor is please make it virtually smaller. So our height is always virtual 512, right? Actually, something is wrong here. Why? And what we want to do now is actually here, we want to do the same for left and right. So okay, just to, so this is what we scale the width and the height. Did I mix up width and height? No. So this is self.size.x times scaling, and this is self.size.x times scaling, right? Now this means this changes the scaling, but this just uses the scaling from this to keep it square. Something is wrong here. Well, what is wrong with my math right now? Something doesn't feel right. So up and down changes the scaling, right? And left and right just shows more. So this doesn't change the scaling, right? But oh, this should be bigger because we basically this is virtual pixels, and if we make the window double the size, every pixel doubles in size, and if we make the window smaller, then every pixel gets smaller, but this doesn't change it, right? This just says show more on the left and the right. So that part is working. What obviously is not working, we have this mouse thingamaboo here, right? Basically, what we could do is we do need the scaling here, right? So what I want to do is we have a size and we have a scaling, and that's a F32, and actually all the scaling we do calculate down here. We calculate down here. Let's remove this. Let's just say let scaling equals self.scaling, right? And this is actually how we calculate scaling up here. So we say let scaling equals this, and self.scaling is this. Right, so we remember the scaling because we need it in more than one place, and right now we gained nothing, but we're very close. I need a quick break, I'm sorry. Sorry about that, and obviously we did miss the scaling and the initialization. And the scaling actually we don't technically need it here. My brain is currently a bit frazzled. So this is still working, right? I mean, ignore the flickering because that's just but what we want to fix now. So step one, we fix all the other things here, right? So we know test texture 2, is it actually the same size? It's also 64, but we want to make that twice the size, ignoring that we don't have the pixels, right? Don't do this in a pixel-based game. And obviously everything that's textured, now that's gonna be a bit funny, but let's say we want a, I don't know, 16 by 16 quad? Well, let's make this 32 by 32, right? It's pixels now, and it does only work for the textured shader at the moment. So if we do this, yeah, if we do this. If we do this, all our drawn stuff is at the wrong position and our mixel stuff is wrong, so we totally messed that up. What did I just do? This is textured, right? So, oh, this position is in pixels now. So let's say our screen is 1024. Let's put this at, I don't know, minus 256 pixels. And we know it's 1024 high, right? So it's the top would be 512, but then we say minus 0.5 times 64, right? So in theory, all coordinates are pixels now, which is what we want for the pixel-based game, right? For 2D pixel-based game, doing calculations in pixels is much easier. So this means the test texture 1, if my compiler would cooperate, this is gonna cost us time. So this is now flush with the upper border, right? And no matter what I do, it will be flush with the upper border. And that's very helpful once we start to do UI stuff. So that is nice, right? So obviously there's more space to the sides. So technically the view would be more like this. And let's put this in at the bottom, right? Let's put the 2 at the bottom and we basically do the same. And let's put it at plus 256. Well, let's say if it's 16 by 9. So if it was square, if the screen was square, we would put it at 512 minus 0.5 times 128, right? And the same actually, oh, we want it at the bottom, so we do minus 512 plus half the size, right? This is one piece of the puzzle. So we can position stuff now. This with good precision in coordinates we understand on the screen. Yay! If Rust wouldn't drive me crazy with a missing dot zero and a missing dot zero. I would just implement the trait, but I'm outside of the scope, so I cannot touch that package. I just love how the little fish swims up there. It's very relaxing. So this is exactly in the corner now, right? On a 512 by 512, which is very uncommon. And this is exactly up here, and the bottom one stays at the obviously stuff can go off screen now. So stuff can go off screen. So where did all the fishies go? What did we do wrong to? Okay, step 1, let's reduce the debug noise here, right? Let's reduce the debug noise here. So the default effect doesn't know about the model view projection matrix. That is correct. Right, so this is default, this is textured, this is rendered textured quad, and this size here basically is is dumb. So let's say 64. Well, let's just say that the size here is 32, right? Because we have that in there. So let's make them all bigger. And then we go into the default shader. And the textured fragment vertex shader knows how to do this, right? But the default vertex shader has no idea about this. And it has no idea about this, right? So we need to multiply by the MVP basically. But that's just standard. So let's add that. We fix the shader and we fix the size here. So probably Mixel will be broken now, but I don't care about Mixel. Oh, I care about Mixel. Let's fix that up as well. So this. So we do have a lot of fish here in the middle now. And somehow our... So this is the ring. Okay, the ring now uses wrong coordinates because basically we say maybe we multiply this by 512 and well, let's do the 512 multiplication here. This is hack to have something on screen anyway, so I don't care too much. And the click positions are currently wrong because the mouse positions are wrong. But the size should be correct. And here we have sizes that make sense, and the cursor position is obviously our next thing that we're gonna fix. We will fix the cursor position in a minute. And then everything should be back to normal with the fixed coordinate system, which is a big relief. And we fixed the aspect ratio problem as well by doing this. Oh, yep, this is now a perfect circle, and if we change the height, everything gets smaller or larger. And if we change the width, we just show less or more. And that's exactly what we want, right? So if somebody has a very wide, ultra wide screen, he can see more of the level to the right, but he can't. And that's just what we want, right? No black bars or stupid stuff. Might be unfair in a strategy game when somebody can see further. I mean, that's a different story. And obviously, the mouse position is still wrong, so this fishy should follow the cursor, right? Which it doesn't, because... So this assumes this position here is normalized, right? So this is... so we need to multiply this by... Actually, is it just multiplying by... Is it just this? Nope, nope. It's basically this, right? You could argue that maybe whoever creates a window context should just give us pixels, which could be true. And this is a Y, right? So scale it by the size of the whale. Worst case, I have double scale now, which I don't think I do. But let's see. That's a quick one. That is a quick one. So our cursor position Seems to be correct if we don't resize. I mean, I'm not sure where exactly the center of the fish is, so it's a bit hard to tell. So if I scale this up now, if I scale this up, I have a scaling on the mouse now, and I have the same in the, the almost. I'm not sure why all of these are white. Oh, okay, I know why they are. Ah. So what we have to do here, we also have to multiply by self.scaling, right? Either by self.scaling or 1 over. So either multiply or divide. I think it should be divide, because bigger screen we had a negative factor, a factor lower than 1, so I think it should be this. And this is 1 float per frame, so performance should be fine. Coffee refill. Is this compiler getting faster? So this is just a scaling of 1, right? So that's the easy case. So what if we... Well, this feels right-ish. So what if we make the window much larger? This feels good, right? This seems to be correct. So all our scaling and mapping and coordinate system stuff is... Obviously the textures do look abysmal, and I'm well aware of that. But that's some... I want the color back, and actually Mixel is totally broken now. Because... let's open Mixel. Because Mixel is actually using... Oh, this is interesting. Because basically Mixel does the same. So what we could do, we could just copy the scaling, right? We could just scaling f32, scaling as 1.0, and then we just do this on the... basically we just need the size, right? Let's copy these two and also keep the size. So technically you would only have one system that owns this information, but since this is a hacked in subsystem, I'm okay. And then just in the update it basically does the same thing, so it knows the size and the scaling. And then when it actually renders here, it could just say self.size, right? It doesn't even need this scaling technically. It will just scale it to the full screen now, which is probably not what we want because it will kill the aspect ratio. Maybe we just want the grid that's not the full grid. The grid not the full grid. Obviously, first use of size. Wait, what did I do? Oh, we have size. This is window size, right? Window size, and this is window size, and this down here is window size, and this here as well as. Now I'm sounding crazy. I know. I know. Oh, scaling. Scaling obviously also needs the window size. And actually the window size. We want to apply the scaling, right? Do we? Maintaining this pixel thing. We need to multiply that by 2. Right, so we need to multiply this by 2, and we actually need to multiply this by so self dot window size dot x is times self dot scaling times 2, right? And then we do the same for y, and then we should be fine. So the window size is more the canvas size, but it's Mixel, and Mixel is a hack inside of the toolkit that maybe I should just delete it. Maybe I should just delete it. I feel like I'm burning up. So enable Mixel, and this is now the full screen, which is nice. And it scales correctly. And if I make it wider, oh, 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 oh. Right? What's going on? Am I allergic to something? Oh. Mixel. Set some pixels. Oh. Yeah. We need to fix the X, not the Y, right? That was just... We want to keep the square square, so... Technically, we could just set the window size to... We could just say... X equals Y, right? We want it to be square in pixels. So if I do this, it works, and if I do this, it doesn't, because I was doing Are we doing anything sensible right now, or are we just hacking around with broken data? My brain is just twisting in a loop. Cold sweat on his face. Oh, now the ×2 is. Whoa. Now what did I do? Now what did I do? What if we just set the... We don't want the window size, right? What we do want, basically, is... Oh, this is a multiplication. No, this was supposed to be an assignment. Time to take a break? Maybe. I want some animated fish on the screen before the end of the day. So let's turn on Mixel. And this looks good. And if I make it smaller, it scales down. I make it higher, it cuts off, and it's still there, right? So the best demonstration of using the full height and expanding the width and just ignoring that. For stuff like backgrounds, we will have to fix that, right? So I would say Mixel also works, and our drawing on the screen works. Our rainbow color thingy is not working, but that's actually nearly trivial. That's the default fragment shader. Right? Is this correct? I mean, it's a constant, so let's make this a constant. So yeah, upper left is greenish blue, upper center is blue, center is green, and corners are cyan. So that's the old behavior, right? And that's fine for me for now. Maybe we should make the drawing stuff a bit, these things a bit bigger. A bit bigger. Weren't they supposed to be... We use fish in the circle, right? Oh, this is a click position and this is a fish. Okay, that's fine. So last hack, I think then we do a little cleanup round and commit this. Okay, so yeah, that feels nice, and I want to go back to the default aspect ratio thingy. So somewhere here we have this other dimensions again. And don't worry about the assets and the texture rendering, you'll fix that somewhere down the road. It's on the roadmap already. So, this is done, right? And you could argue that we can tweak the fish to look better, maybe make the fish in the circle actually pixel perfect. So the fish in the circle, the size is 64. All right. Wouldn't it be nice if you could stem fish? Yeah, this looks better. Maybe increase the radius of the circle a bit, but that would be playing around. Oh, I just realized something totally unrelated to what we're doing. Our key, it's actually two keys. No, actually it's one key, so I'm not sure that priority ever was used. There's a key calculate sort key texture IDs. So the render effect has a priority. So the render effect knows its priority. That shouldn't be needed. I mean, I want to fix the layering at some point and the render passing, but for now, no. We're getting totally sidetracked. So, to do, we add support for MVP uniform. We added the very basic matrix struct, and we use the correct orthographic projection, right? So let's move this down here. And we did a lot of stuff already in the last few days, so that's down here. And now let's make a clean commit. So we use we fixed the color here, which I won't even mention. We use MVP in vertex shaders, and that's both of them. So in the default and in the textured one. That's all we have right now. The fish app does the right calculate correct scaling for fixed height of 1024. Adjust all test quads to new viewport size. That's that stuff here. Patch up Mixel to work with new viewport, new projection, new MBP. Technically, it's the viewport, so that works. Matrix full 4 hooked up, render pass through the MBP. Allow setting of MBP for renderer and material. Right, so this is the MBP and the renderer. I still want to get rid of this 0 at some point. Not sure how yet. That's the size hack, and add window size to window update context, which will be handy, and adjust mouse position to new pixel based coordinate system. I mean, we won't be using the mouse, it's a one button game, so stage this, window update context, and I'm not sure what I clicked there. And then matrix 4.4, yeah, maybe that old C code doesn't need to be in here. This is just straightforward orthographic projection, so nothing magic in there, so nothing to explain, and we have the nice debug formatter here, so let's stage this, commit all of this, rebase this, and push this, and even though I don't feel that well, the system is slow-like. All of the changes are committed 8 minutes ahead of schedule. Yay! So it says add basic fish movement, and we could start to do that. Actually, add basic, add game logic wrapper. Right? So we're doing all in the app, and that's kind of maybe not. So let's add a game, right? And the game and the app interact very closely. So the game is the pure gameplay, and then you have a UI layer and a meta layer for difficulty selection and stuff. So not even sure we want to call this game, but we will. Right, so we are gonna do a touch source Fiiish game.rs, right? And then basically the nice thing is if we look at Mixel and then we look at game.rs, and actually we're gonna hook that up in fish.rs. This is gonna use game, right? So this is pub mod game. If I do in game now, basically Mixel is a game. Mixel is one of the games we support, right? So you could just say well, we derive debug because we know we will need it anyway. Pub struct game. Some stuff to be done, and then we have an implementation for game, and that will have some setup, and then we have an actual setup that gets the system and the renderer. So we just copy this, right? We just copy this, and then we have a tear down, which we can just copy, which will need to do something at some point. Then we have an update, which probably will do something as well in the future. So does the game get the full window update context? I'm not sure. To decide if we need the full window update context here. Probably not. I'm leaning towards no. And then we have a render, right? We have a render that renders the game, right? And that is all. And then in Fiiish app, the app owns a game, right? So the game, and then in the new we say game as a game, and probably we need to do the use. Why is it super? Oh, because Fiiish app. Oh, I don't want to use super. I want to use create Fiiish. I'm gonna regret this. Game. So we add that in the setup at the very end, where we say, actually this is nice. Self.game.setup. I mean, basically it gets the render. It's just the same, right? It's just the same. And maybe we have an interface for app components, a trait at some point, but right now I don't want to go there. Then tear down is the same, right? Tear down in reverse order, please. Which does nothing right now. Is done, we only handle the escape, and then basically the update. In the update, we always do self.game.update, and that gets the VOOC for now. Not sure, and then before we finalize the frame, we basically say self.game.render, right? So far, so clear. This is just our basic game wrapper, and we will have probably some intermediate steps for like abstracting the state. Are we in the meta game, the shop menu or not? What did I forget? Oh, window update context not found in game, which is fair. Because we weren't sure we need it, so... And we need the renderer, and we need the color and effect and texture anyway, so we might as well just push this in, and we need the system. Right, do we? We need the system because we're actually... So we need the renderer, but we don't need anything else right now, right? We only need the renderer. Only need the renderer, we need the update context, we need the system, right? That's all the game needs at the moment. Oh, this one is good. In the new, probably we want to new this, right? So now we have the game hooked up to our, and actually what I will do, no, I won't do that yet, but I will add it to the to-do. I want to, and I'm gonna put this somewhere here. No, so game is running. I want to extract demo code out of Fiiish app. So all that Fiiish app thing, all that stuff here, all the noise, all of the, well, not this, but all of this here could just be a module, right? And then this would become very clean. It would just basically render all the submodules. So we do have a game now. And let's say I don't want to have a full entity component system yet, and Fish probably will never benefit from one, but I want to create entities, right? So Fish has entities. It's just the fish is an entity, the rocks are an entity, the coins are an entity, the squid are an, oh, you haven't seen the squid yet. The jellyfish are an entity, so we have entities, right? And I want to do the usual touch source fish. Usually it would be this, right? And this is just ugly, so I'm doing this. And then I want a fish. Do we have a fish.rs? No, we don't have a fish. We have a fish.rs, so we just call him the fish. Fish, we just call him the player, right? This is the player, just to avoid, and if you want to play with a spaceship, be my guest. So this is the player, right? And I'm not gonna use traits yet. So we have the entities rs, and the entities rs is mod player, and that basically has a pop use player as play. No, that was the one I wanted. Right, and then we have the player derived debug pop struct. Yes, all of this should be pub crate probably, but I don't care for the moment. And just because we like doing this so much. And I still don't have a macro, beat me, sorry. The player, and then somewhere in fish.rs, we basically have pub mod entities, right? Just to hook stuff up. We probably could create a helper that says, hey, please create a helper for me and hook it up. So add entity player, done, right? So that is done. And now basically, I mean, So how does an entity work, right? We have the player. I'm not sure how I want to do the input routing. So in the old Fiiish, I'm not sure if I, oh, let's go this, right? We had explicit, we still had the initialize and shut down, which is basically the setup and tear down, because initialize and shut down sounded a bit. We have the update, which probably, oh, we have a game update context. Yeah, we will have a game update context. And we will have an object manager at some point in some form. And then it has a lot of specialized stuff, but mostly it has the update, and it does have, because it is a game object, and game object have a render method, right? So, and game objects just have a default implementation for rendering in C++. Yeah, I'd probably say the Fiiish doesn't handle its own input. The player object is told what to do, right? So we will have a setup. We will have a tear down. It's just our. There were reasons for splitting constructor and initialize in C++, for example, serialization. Let's see how far we get with this. We have update. Update, and yes, all of these are mute self. I always forget this. I always forget this part. And they will get more parameters, right? There will be more parameters. Actually, maybe we pass through. Ooh, interesting. It could be chainable. And then we have the render, right? And we do know that the render will need the renderer. We do know that, right? Come on. And here it becomes interesting. So in a component, in the setup, we do stuff like load our textures and stuff. So we create textures that needs the system. Well, why does create canvas need the system? Why does create canvas need the system? It doesn't, right? It does not. The create canvas from file would need the system, but so we assume that the game entity is lightweight. So if I know that the game will need a fish animation, I don't load it when the entity is loaded. I load it because I know it will be loaded. It will end up being in the in the come on in the atlas anyway. So this no loading. No loading at this point, right? I think. Rust makes this so hard to make this clean, and I'm still not sure. We're doing overtime anyway, right? So what do I actually want? So if I go into Fiiish app, what do I want for now? All I want is to render a fish somewhere, right? So basically I want this, right? So I want a fish to be rendered somewhere, and this use texture to be defined. Not sure, not sure. So we have a position, right? That means we need a vector too. That part is easy. So I wish there was a macro that said, yeah, if you say use v2, I know what you want to do. So we have a vector 2. That is the player position, right? And this would be the first component if this was a component-based system. So pos is, so it would have a position component, right? So pos is 0. So this is just self.pos, right? And actually what I also want to do is, and the size is vector 2, and this is not 0, this is new. Let's say 128 by 128, just for now. Would be nice if we could ask somebody, I mean, for example, maybe this would tell us the texture size and we could just say, okay, if we give you a none here, just use, but that would mix game logic with, right? So if we hook this up, this will just render the fish, whoa, smack middle of the screen. So let's hook this up in the game. So the game, use create Fiiish entities player. I still don't like the module structure, but let's say we have a player option, right? We have a player option, and this is set to player none, right? And let me say we have a list of players. Let's say we have a list of players. We have a vector of players, right? And it's always easier to iterate over a empty vector than to skip a none. So what do we do in the update? So here's the thing. Here is the thing. Here is the thing. Let's not overthink this. We know we will need this to do this differently, but for now I just say for p in self.players.iter, and that's actually mutable, right? For every player we just call p update with the update context, and in the renderer basically we do the same, right? For p in players we do render with renderer. these will live inside the entity manager at some point, but I don't want to do the entity manager. So that is a pure update. There's no input handling involved, right? So what if in this setup we say actually self.players.push actually let's say let p mute p equals player dot new. Actually, we could do a setup here, and the player setup gets nothing reset, and here we just push the player, right? So let's always have one player, and in the tear down, it's gone anyway, right? We should probably iterate over the existing players in the tear down, so let's say yes, we're making our life intentionally hard with this, but there's a expected 0 arguments for the player update. Yeah, we set the player update. For now, gets nothing. We will need an entity update context. We will need an entity update context. That's actually... And obviously it's players, not player. Expected. Wait, what? Oh, we can't chain this because the setup... I'm not sure what I was thinking there. Maybe it would be nice to be able to chain these. Maybe that would be nice. Fish. Oh, we don't have effect ID in the player. That is correct. Because we didn't do any. Actually, let's use... Where does effect IDs live? In Fiiish. So use create Fiiish effect ID. Oh, we need the... Yeah, not a fan. And we probably need to use the renderer, right? Yeah, we need to use the renderer. Oops. Oops, oops, oops. We don't need the color. We don't need the effect. So we just need the raw renderer here, right? Maybe we should move the demo stuff into the demo stuff. Oh, bad headache. Okay. So, fingers crossed. One more fish. One more fish on the screen. Yep, one more fish on the screen. So this actually in the middle here of the screen is a player fish, right? And this is the player fish. So the player fish has a state, right? The player fish has a state. Correct? It's waiting for start, it's swimming, it's dying, it's dead, right? Let's build a little state machine. Let's say derive debug, yes. And let's say pop enum player state. Probably doesn't even need to be public right now. So wait for start, right? So this is swim in place, do nothing. Playing, well, let's say swimming. Swimming, dying, and dead, right? So we have a state, and that's the stater, and that's the player state. And the default state is player state, wait for start, right? And then actually every element has a name, right? Yes, we have a name. Everything is named, and we should have IDs. But for now, let's just use names for this. So string. Don't over optimize here. So name as string new, and here we say self.name equals name to owned. Actually, I'm gonna look this up now. I always say I Rust to string versus to owned. I never know what's idiomatic. What's the idiomatic way? To owned, to string, from. So basically they say we don't care. This makes sense, yeah. So we use to owned from now on to get string slices into owned strings, because that's what it does, right? That makes sense. So we have a name, and obviously we have a getter for the name, right? And that will just give us the self.name. So the reason why I do this is game. So in the update, I say, so when I create this, this is the player, right? And right now we only have player, but give me a second. So I say we explicitly iterate over this twice, and we say if p.name equals player. Then we say, how do we do this? How do we do this? Basically, you want to say if space is pressed. So if book is space pressed, else we say p dot turn down, right? We swim down. Otherwise, we say p dot turn up. Not implemented yet in the fish, but in the player. So what if we had a turn down and we have a turn up, right? So if match self.state, if we are in player state, wait for start. We are in wait for start. We are in wait for start and we want to go to a different state, right? So let's say we have a function, go to state, mute self, state, player state, right? So if we in wait for start, we actually do self dot go to state, player state, swimming, right? If we were in start, we go into swimming. And that's the only thing we do, right? Actually, in all other states, we do nothing for now. We do nothing. If it die, well, if you're dead, oh, that's interesting. How do we do the respawn? So we have a pub function that says respawn, right? That basically we have state machines and manually do transitions now, but if the state is dead, and only if we're dead, not even in dying, we can go to wait for start, right? Maybe the default state should be dead, because dead means don't render, right? And then the game, deep into game logic, so I say just respawn at the beginning, right? Just start, and that would be wait for the first space. Actually, we have. I'm gonna close some of these because we don't need them anymore right now. Yeah, and I closed the wrong one again. So the to-do I want always open. To-do is open, game is open, and player is open, right? So the player is alive. Do we? Is alive. Maybe just get state. Maybe just, oh, is alive. Is alive. Self, and that just returns a bool, right? And is alive says, and again a big match on the player state. So is alive basically says if we're dead or player state dying. Well, let's shortcut this here. Then we're not alive. In if we're in player state waiting for start or player state swimming, then we are alive, right? So the game says during the update, if space is pressed, if P is alive. So if the player is alive, we turn him down. Otherwise, this logic we say P respawn, right? So if we're dead, we respawn. If we're alive, we just turn down. And in any other case, we just turn up. Well, let's do it like this. We could probably just say, okay, you told me to turn up, but I'm not alive. I ignore you. But this says, okay, in the dead space, in the dead state, space respawns, in the life space, dead. Oh, oh. let's turn this around. So if the player is alive, else. So if the player is alive and space is pressed, we turn down. That makes the logic a bit clearer. Else we turn up, right? This is gameplay logic, that's external. If the player is not alive, for now we just respawn, right? We just auto respawn. To do handle via UI, but we don't have UI yet, so we don't even respawn, right? So no respawn. So in the player, if we are dead, if self.state equals player state dead, and we just return, right? This is just early out. That means off screen, nothing to be rendered. And we could probably have a match and then have render dead, render dying, render alive, render waiting for start, render invincible, but let's keep it simple for now. So then we have going down bool, right? So the default state is going up. Going up, going down is false. Probably we could have swim direction. So if I say turn up, self dot going down is false, right? And if I'm in turn down, if I am in player state swimming, only in swimming I say, I'm not sure why I always hit the wrong brace here, self dot going down is true, right? Turn down means go down, but only if you're swimming. If we're waiting for start, turn down means now start, and basically we hold space, so that should be fine, right? So in the update, what we could say is, and to do time step, we could just say if self dot going down, and we say self dot, and we're gonna fix this in a second, self dot position dot y minus equals, let's go 1 pixel per, just to see movement, right? So if you're going down, we're going down, and that should probably be a vector multiplied by the time step, direction, tweaks. Oh, lots of stuff I forgot. Yes, I always do this wrong, and even while typing I thought this might be wrong. Go to state. Oh, 62. Yeah, obviously. That is true. Go to state has to do something, and right now it just says self state equals state. To do handle transitions if needed. Oh, because we have no EQ and no partial EQ. We need the EQ trait for comparison. I mean, for equality, we need the equality trait. Okay, so if I hold space, the fish goes down, and if I let go, it goes up. I'm not sure why it... Oh, okay. So I can go up and down now. See, fish game done. Just keep the fish in the fish circle. It shouldn't go up on start. It should only be moving in any way. So only if this, so the update is state dependent, right? So what I want to do is match self.state and say only if player state is swimming, and then I'll do this logic for now. Right? We probably separate that out. We should probably say fn update swimming, right? Swimming mute self. That's probably the cleaner way of doing it. So in the swimming state, we do this. And here we just call self.update swimming. And we have to pass through some parameters at some point. And all other states for now just do nothing, right? This means we should initially be in the state waiting for start. Well, we should be in the state dead. Then we go into the waiting for start state, because respawn is triggered, and then so we have a fish that's not moving. It's not this one here, it's this one here. So we're waiting for start. The player presses space and starts to go down and can go up and can go down and can go up. Right? Easy as that. So we have basic logic for the game. And the input routing is working, and the logic for the game is pretty controlled here. So there's two things I need to do. And we're doing this right now. We need to be able allow quads to be rotated. Right? We want the fish to do this and not do this stiff motion. And we want add animated textures. Add animated texture, right? So we have the nice little swirly, funny, fishies thingy going. What we really want to do is, so this update definitely needs a context, right? So entity update context, oik. That's a mutable reference to entity update context, right? Which doesn't exist. So let's create that. So touch source fish entity update context, right? Let me say entity update context, do our usual sing and dance pub entity entity update context, and we know this will have a time step, which is a F64. And then we have an implementation for that, and that basically has a pop function new with our self sing and dance, and the time step defaults to 0. And I actually want to make this public. Just do what you want with it, right? Well, maybe add a getter. Somehow the syntax highlighting seems broken here. Does it look broken to you too? Oh. So this is the entity update context. We have to hook this up in Fiiish and say pub mod entity update context mode, and actually say pub use entity update context entity update context as, and actually that means not sure about this pattern yet. Obviously the player needs to use the entity update context now. Use create Fiiish entity update context, and probably we pass this through to the swimming state, right? And then the game actually has to use the same. And since the game actually, well, Fiiish is down here, so since the game actually owns all of that before the update, basically here it needs to say let oig equal entity update context new, and then here we just pass in the mutable oig, which means this needs to be mutable, right? Time step will always be 0 now, which is not nice. What did I do? Oh, I know. Wait. Yeah. Nice try, my friend. Syntax highlighting is broken, right? Yep, syntax highlighting is broken. I will need a break at some point. And now I'm gonna do something weird. I'm gonna say pub fn set time step. We'll actually get mute self. And return a mute self, and this will just say self dot time step equals time step, and we'll pass through self, right? So we can do crazy stuff like this. So in game we say dot set time step, right? And that's walk time step. Can we? Does this work in Rust? Almost. No method set time step found. Oh, okay, so this probably could just be self, right? Yes, and that means then in player, in the swim, we actually have the speed. So we could say times EOC dot time step SF32 bit set that we have to cast here, but we haven't run this in a long time, right? Let's run this. So, oh, this is moving 1 pixel per second now, which is probably, can you even see it? One pixel per second. Maybe we should have a speed, right? Speed? Speed. And the speed defaults to, I don't know, 10 seconds for 1000 pixels, so 100? We can tune this, right? So this is just self.speed. Probably will be angle dependent at some point, but let's not mix everything up right now, because you basically don't go up and down, you change the turning direction, and that changes it. That makes it much more fluid than the, you know. So 100 pixels per second. Yeah, that sounds about right. Shall we say, just for now, if we go out of scope, out of screen, is this insta-death? So, let's say when we update, and when we're going down, and then say if self.pos.y is larger, is smaller than 512, right? It's to be defined boundaries. I don't care. Go to state, player state, dying, right? We just go to dying, and then in the renderer, actually, we say the only difference in rendering is if. So let's match this. Match self.state, right? If player state is dead, then we're invisible, but dying, or player state is dead, then do this. In all other cases, just do this, right? And gonna look up, oops, I'm gonna die. It's fish die. Die 0, 0. So we have a fish die 0, 0, right? If you're dying, we use the die one. Obviously, nobody loaded the die one yet, so the game better gets this game up, because it's basically just piggybacking on the fish app here that registers the textures, right? Oh, this is interesting, cause right now we register the same texture multiple times potentially. So let's say load textures. We do this and we do this, and this will go away in a minute because we'll do the Atlas stuff later. So this means potentially avoid duplication in texture manager. Basically right now it will just be appended at the end, and then we have 2 copies, but only the first one will be used, which is not so good. So technically we could just say if we go down here, the use texture just says, hey, I would like to use this texture. If you have it or not, I don't care. Better make sure you have it soon. So we could have a callback in the update that then lazy loads textures and renders invisible until we have the texture, or just white or default texture. But let's not go there. So the game now loads the fish swim and fish die. We do die. We go to dying when we hit the bottom. We need to do something, and we render differently when we die, right? And otherwise we just render the same. I want to do some game logic, and then we do the matrix multiplication rotation stuff. Oh, obviously it's just a system here, right? It's just system. Texture not found in this scope. Fair enough. We probably have a helper that is a texture loader that is a bit smarter. I mean, in theory, we don't need to register anything. We can just say, let it run. Go to state. Obviously, it's self go to state. It's cell. I will mix that up till my last day, because it's so ingrained that that methods on the class are automatically found, so you don't have to have the explicit this. So we're in waiting for start. We insta die. You saw that? We insta died. Why did we insta die? I mean, it looked cool, so. Oh, we checked if we're below the upper border, which we always are. So we go down, 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 we hit the bottom, and we die. And what do dead fish do? What do dead fish do? Oh, come on. What do dead fish do? Dead fish update. dying, that means here we just say player state dying. This could be a data structure instead of hard-coded. What do dead fish do? Yep, they go up, right? If we're dead, we go up, and then we basically say if we hit the top border, well, if we're off screen, right? So let's 512. If we're off screen for a bit, so dead fish goes up, we go to state dead. I mean, that will not be visible to you or me or anybody. So, waiting for start, swimming, 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 swimming. Let's pretend we hit some obstacle, in this case the ground. Ooh, fish dies and swims up. And that will also be the turning, automatic turning up and then accelerating based on the direction. So obviously we have no way to respawn the fish now. So that's not good. So basically what I want to add is we have the is dead, is alive, and we have a can respawn, right? And basically pop function can respawn. And we can only respawn if we're dead, right? So self.state equals dead. We can only respawn if we're dead. We cannot respawn while we're dying. So in the game, we say if player is not alive. Ooh, it should be respawning. It should be Why is it? Right now it's respawning very aggressively, I think. But respawn is not implemented, right? Oh, interesting. I mean, obviously we only want to respawn if we're dead and can respawn, and that will be handled by UI anyway. This is a do you want to play again? So we swim down, we die, and we constantly respawn now, which we obviously don't want to do. So we want to say if P can respawn. If we can respawn, then we do that, and only then. And then obviously we have to implement the respawn in the player. And that says if we're dead, we go to wait for start and go to state actually match state wait for start. So all these states have some settings like self.pause equals vector. Oh, come on, vector 0, right? We need to reset the starting position, for example, and animations and colors and all the other states just don't do anything because they don't have to. We could enable keyboard, for example. There's different ways of handling that. We could have a state machine that has traits in an array or a vector that then are dynamically are dispatched, but obviously we change the state at the end. Because there might be different behavior based on from which state we go into which state, so we need the old state and the new state, so only change it at the end. Or you could even move the state change in the match and say, going from swimming to dead, something is fishy here. I have to stop making these fishy jokes. Or otherwise I go like trout, salmon, cod. No, no fish jokes. This is a fishing game. This is not a joke. So we can swim. We hit the bottom. We die. It creates a new material because it doesn't know the combination. So we are dying now, which means float to the top. We are dead now, and we respawn. And then we can play again. So basic player interaction loop is done. Alright, so I can swim, 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 hit the bottom, die. Game over. UI says, hey, you died. Funny stuff happens. And you float to the top, probably should be accelerating, and play again. Obviously the whole left to right movement is, and actually, here's a big trick, the fish is not moving left to right. The fish is just staying there, and probably we move the fish more like here, right? Here feels right, so 1/3 to the left. So actually let's do that. Let's say we have a start pause, a spawn pause, right? A spawn pause vector 2. And actually the spawn pause is vector 2 new. Let's say 1/3 to the left. So let's say -256 and smack in the center of the screen, right? And then on respawn, on where's the go to state? Where's that? There's the go to state, right? We set this to self dot spawn pause. And now we don't spawn in the middle of the screen, we spawn slightly to the left, I hope. Yeah, that was not far enough. So this was double the amount we currently have. So let's say this should all be coming from a config file anyway, or the level editor. Maybe the starting zone has a spawn position baked in. So what do we want to do first? Animated textures or rotation? I think animated textures are much easier, so I want to go for rotations. Yeah, that's better. That is actually much better. I would love to add the background, but the background does some serious magic. So background is probably very late. Doo-doo, 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 doo-doo. Wouldn't it be nice if it was animated? I mean, first clean this up and commit this, because this is actually valuable, right? This is pretty cool. So what did we do? We added the game logic wrapper and we added basic fish movement, which needs to be tuned, right? So So add fish, rotation, and use direction for movement. Well, that's probably here. So, but we did this. We have some basic fish logic. Add basic game logic. Add initial player logic. And this is, I mean, we almost have a game right now. I mean, just keeping the fish in screen is already, yeah, we should add the upper border des. We should add the upper border des, actually. So player. Basically, we say update swimming. Sorry, have to check this real quick. Oh, thank you. Easter chocolate incoming. So basically we say if we hit the upper border, and probably we over optimize here, so if we hit the upper border we also die. I mean, if we don't do this, if you don't press space, the fish just swims up and you come back from your coffee and the fish is like 15 miles up and you are like, where's my fish? Sorry. Where's my fish? Hey dude, where's my fish? Oh, that's another good game. Dude, where's my fish? So if we hit the upper border, we might be able, if we very carefully wait for it, we can see that it switches to the die and then respawns. So that's good. That's better. I like that. So this is adding the entities. Adding the game to the fish app is nice. All the standard component setup stuff. We added the concept of entities. We added a player entity, which is the fish, with most of the game logic in there. Well, most of the player movement logic in there. We have the update context, which is just a wrapper for the time step now, but we'll have more stuff. I mean, for example, the fish is spawning little bubbles in its trail. So the bubbles. Ooh. Ooh, let's do bubbles. And then this is just the game logic, which again wraps a bit of stuff. So, yep, we have a swimming fish. So I will take a 10-minute break to relax my back and sit down for a second. And then I probably check it on the Windows machine. Let's do it. Let's check what Windows is saying. I don't need CUDA for this. Where's my dude? Where's my window? So I do a fetch. I need the second screen hooked up, right? Rebase and run release. This machine is so much faster, but I can't. I don't want to work on Windows. It's just no. So the mouse positioning is correct. The movement is a bit slower, I feel. And the dying logic and the respawn works as well. And window resizing on Windows totally messes up the so Windows, yeah, we have this GL viewport, right? Which basically says, hey, I want this viewport. And apparently WinIt under macOS, when you resize the window, automatically sets the viewport to the full window, and it does not do that under Windows. So what we could just do is, where do we do this? Is this a renderer task? should the renderer before it starts to render, or even and begin frame, should the renderer currently doesn't know the size, right? The renderer, it's funny, but the renderer doesn't know the size of the, we're not fixing that right now. We are not fixing that right now. I'm gonna take a 10-minute break and then I'll be back. See you in a bit. No, not ghost fish swimming alone. Me just being funny. So, bam. This is starting to look rather nice, right? I mean, we still have to write the full UI system, but okay. So what did we say? Rotating fish or... So here's the thing. We want the same behavior as the original game, right? So when we look into the fish movement now, we should use the same logic as the original game, even if it's not perfect. And okay, so our direction is, what's direction float? Okay, so it's up, down, and float. Oh, so our bool is actually, huh? That's interesting. So float is actually used nowhere. And then down, for example. So if we turn down, we go down. If we turn up, we go up, and otherwise we float. And then basically we just rotate the angle. We don't change the, so we rotate the angle. And then we have an approach angle. I'm not sure. Oh, so for dying, we have a, hey, go towards that angle, whatever your current angle is, which is fine. I mean, and this is actually acceleration. So if we're dead for longer, we accelerate, but that's details. So let's do the angles thing, right? So instead of moving the position, we move the angle. And then the position is actually the sinus of some black. I have no idea what this value is. Now this is interesting. So the more we rotate it, the faster we accelerate. But isn't that just a vector? Well, here's the thing. Let's keep the original logic, right? And I don't even know what angle range for y does. Oh, so, okay. We have to run this because this is hard to explain. Actually, we can't die at the border because if fish would start at some point, because we bounce off the borders. So if you go down, you see in the middle the angle is pretty steep, and I have to find an empty zone. So if I go here, I get pushed back towards the middle, away from the border, right? And the same, let's get an empty space. The same is true at the top, where you see the angle gets flatter. So basically the fish wants to turn, but it's pushed into the center lane. So if there were no obstacles, we would just swim forever, right? And since we want the behavior of the original game, if we like it or not, this is where the remaster comes in. We have to actually do this, and I mean, So basically, if we're in the top half, the minimum angle is this, and the maximum angle is this, and that's so this is the absolute limit, and that is a reverse range, and we are not doing the angle limiting now. So to do future limit fish player slash fish angle at boundaries. So we're not doing that right now, but what we will do is, and I kind of like the float thingy. So instead of having a bool, we have this direction thing, right? I like this. So we have a direction up, down, float, and float basically means just stay where you are, and that will be nice for debugging later. So I'm gonna allow that. So the player. Step 1, replace this going down with a state, right? And actually, let's do this. Enum player direction. It's clearer than the bool anyway. So we have up, down, and float, right? So we have up, down, and float. So we have a direction. And my keyboard did that weird thing again where it switches windows randomly. I'm not sure how. And that's a player direction, right? And the going down will be gone, and the default player direction is just player direction float, right? So just float, do nothing, and that actually makes our handling easier. So everywhere where we had the going down, so if we have turned down, it's actually self.direction is player direction down, right? I'm gonna copy that and just find the next one. And the turn up basically is player direction is up. That's a bit clearer anyway. So if self direction, and actually we do a match now here. So match self dot direction. If it's player direction up, this is minus, so minus is down. So this is down. Down is the first case. If we're going down, do this. Right, so it's this logic here. Yeah, that's obviously what I don't need to do. If it's player direction up, then we do the other thing. So we do this. We could probably just, we could wrap that nice a bit. Let's wrap the logic first. And if the player direction is actually float, we just do nothing, right? So that thing is cleaned up. Let's check if we have any more. I think that's all of them. And obviously this logic here now is wrong, but I want to run it real quick. I have no idea what I've been eating back then to come up with this strange movement logic. Oh, yes, cause obviously, not sure why I put a comma there. And this might help. Fat arrows, fat fingers and fat arrows. And that wasn't even fat fingers, that was my fat brain. If we can get the rotation and the animation of the fish done for today, I'll actually be happy. So the logic is still working, and I just want to check if we die at the bottom. And so there's one more thing I want to do on respawn. I want to go into floating mode. Just because we can, right? Just because we can. So on respawn, when we go to state player wait for start, I want to say self direction equals player direction float, just to make sure we clean this up. And then that's the direction part, right? And then we have the case here, and we just change the angle, right? So we have an angle, and that angle is a float, and we just say minus 120. So, excuse me. So in 1 second we turn 120 degrees, right? So we have a position, and I like this here. So float, yeah, angle, and that's an F32, and the default angle is just 0.0. And on respawn, we have self.angle equals 0.0, and I'm actually gonna do this. And when I turn down, no, not in the turn down, in the update swimming, actually the update swimming self.angle equals, if we're going down, we're increasing the angle, right? So negative angles, positive angles. Probably flip from your angle plus equals 120 times EOC dot time step, right? And we won't be able to see that right now. So that is actually the only change we do here. And then here we do the opposite change, right? So all of this nice code we just created, bye-bye, bye-bye. So right now we just change the angle and don't do anything with this. And then somewhere we do something with the angle. And this is basically the part we skip. So to do port over angle limiting logic from original game, and that developed over time. That was probably, I didn't know. So I'm not sure what's the difference between rotation and angle, to be honest. So rotation is used exactly nowhere. Oh, okay. Okay, so here's the thing. Angle is inside the fish, but the fish is a game object. It's a game object, and the game object does have a rotation. That has a rotation, and that's actually used for rendering. So we don't care in our case about this. So this clips inside, so that's our if. So basically we can say if self.pos is too large or self.pos.y is too small, So if we hit the boundary, then we die, right? There's no reason to do it inside here. And this is the movement logic, right? So our delta y is this. Don't ask. Probably I was sitting there for a day tuning the values and they felt right. So I'm gonna say let a equal self dot angle, right? And then I say a divided by, I'm not sure what this number is. Is this 10 pi or I have no idea where this number comes from. Weird. So we do this, right? And then we get the sinus of this. So sinus. And then we say we do this times 350. Okay, so why 350? Why not 360? And this is delta y, right? This is our dy. So this, we get the sinus of the angle divided by this, multiply by, oh, negative, so multiply by the negative time step. And then we clamp that. So then we don't clamp, because if you go out of bound, but this was the hit the border. Okay, the original fish, it just went like this and then scooted along the border before it had that angle dampening thing. So this is basically, now we have this, we just say self dot y pos dot y equal plus equals dy, right? So we still don't see the rotation. Let's see if this compiles, but we should see the movement based on the rotation. And yeah, so time step is, okay, let ts equal uc dot time step, right? Maybe that's more readable anyway. And actually we use that in multiple places, so let's just say we use ts here, right? Maybe I should have called it time step, but short-lived variables can have short names. Oh man. Yeah, maybe we just F32 is fine here. For time steps, for absolute time, F32 is a bad idea because it will lose precision too fast, but for time steps, F32 should have been good, but I don't want to change the interface now. In double float. So let's check if, whoa. So since I can't see the angle, but it accelerates, right? So I can see that there's something wrong there in the middle, right? There's what's going on? I'm just holding the button. Yeah, it would be nice to see the actual angle of the fish now. So otherwise, it. Why is this bouncing? Why the heck is this bouncing? Why the heck is this bouncing? So Okay. This needs some deciphering. So, but basically we say this is the angle logic, right? This is straightforward. Wait. Down is plus and up is minus. Down is plus and up is minus. So far, so good. Then we have some magic for... Oh, we don't limit the angle. So basically I might have overshot and turned backwards. So we need to do the limit angle limiting. So let's debug the angle real quick. So basically, let's say up here, debug self.angle. I wish I had some text rendering, but we could actually, we're almost there for text rendering. Oh, let's see how far we get. Let's not overreach, right? We said we skip UI this week. He said no UI. So yeah, basically it keeps turning. It never stops turning, right? Even if I let go, it just says plus 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 up 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 up, and then does the. It basically would be doing like this. Be doing like I don't know. I have nothing to demonstrate, but basically it would it's just like doing this and then moving forward constantly. So if that makes any sense. So we need the angle limiter there, which is a good point. And you see it's constantly getting negative, so up, up, up. So we need the angle limiter there. So angle limiter. So we get the angle range. So we have something that dependent on the y position gives us the minimum maximum angle, right? So we have something, and this is just to help us. So get angle range for y, right? And this just gets a y f32 and returns a tuple of f32, right? And this is just associated helper. And this, for now, it just returns this. So what we can do is we can say let min a and max a equal player get angle range for self.y, right? Self pos.y. Actually, min angle and max angle, right? So that's step one. Just get this function, and then we have to implement this function, and we just do whatever the original game did. So that's the limit. Okay, I get that. So the limit is 35 degrees. Okay, let's just copy this over and then do it step by step, because we don't want to change the original game logic, right? So what we'll do is we have a limit. The limit is 35. We have a range. Pretty sure there was some pretty dark magic and long swords going into the formulas, right? And then we say let a equal. It's the sinus of the absolute of y time. Oh, the range is basically the band in the middle where we have full action, and the further out we get, we dampen it harder. So this is basically out of range, and the more out of range we get, the harder we counter steer. So I get this. So and 280 is tuned to the 512, so it's basically slightly more than half of that. So what we do well, actually we do a y.abs. I hope there's an abs. Then we do a sinus, and then we multiply that by the range, right? So we remove the. Oh no 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 no. Alright, so this is inside. So we get the absolute value, multiply that by the range, so that's basically it's like squaring how far it is from the center. That's why we want the, and then we get the sinus of that, but why? I don't get the sinus here. But that's what the formula said, right? So, and then we say let m equals limit times 1.0 minus a. I mean, that's just a to the power of 4, but, and then we say if we are negative, then the min angle is the negative limit, and the max angle is m, right? And if we're positive, I'm pretty sure that could be written nicer, but then we go from negative m to limit, and this base, so this is our range limiter, right? I'm not even sure this will compile. This is when you remaster games. I mean, this is me writing crazy code 10 years ago. So imagine you stumble over the crazy code of somebody else where you don't even know whatever was intended. So did I forget a semicolon somewhere? In line 116. Where does a t come from here? It's y, right? It's the absolute value of y. I mean, the Rust compiler is very helpful, but sometimes it gets in a mode where it starts to tell you stuff that's just weird. Expected, oh, float. Yeah, this is not float, this is let, right? Oh wait, this is the original code which we wanted to let in there for reference, but forgot to comment out. So if we get higher, our minimum angle should start to go towards 0, and if we get lower, our maximum angle should start to go to 0, right? And obviously we were a bit sloppy in the C version, but it didn't matter because 0 is 0. We still don't apply our maximum angle, and this will not be very helpful now, letting this run. But you see, the min and max angle is, worst case, we have minus 35, so we're at the very bottom, so we can go very stiff up, but almost not down. Or if we scroll here, do we have an example? Probably too much noise. But this is a bit further away from the bottom, and the Y would have been more interesting than the angle actually for debugging. But this limiter seems to work. So now we have the limit angles. Maybe we should use them. And all we did is my arm is sending Morse code. What's going on here? Aliens coming? And then we just limit the angle, right? So this is just, if we're out of range, just hard dampen it. Basically this says self.angle. So this is the range the angle should be in, and I'm just gonna add self.y here, self.pos.y, because it's nice for reference. And this is, do we have a min-max for float? Do we have a Rust F32 max? Yeah, if I could write max. Oh, I don't want the max, I want the max of two values. Do we have a helper for that? We do. So this is just one dot the other. Okay. So let's oh, let's rewrite this. So self.angle is, so it's the minimum of self.angle dot min and the max angle, and then the maximum of, do we actually have a clamp? Because all we do is a clamp, right? Yeah, we have a self clamp. So when you don't have a clamp, you can do this min max trick. So you take the lower of the upper boundary and the higher of the lower boundary. But if we can just clamp, I mean, that's obviously much more readable. So that's min A and that's max A. And that means we limit the angle, right? To the range we just calculated with the magic dampening formula. I probably was seriously sleep deprived when I did that. Come on. So let's see. Actually, I'm gonna print these in one line because the noise here is just driving me crazy. So we have the position, the angle, the min, and the max, right? Let's keep the fish on screen. So now we can't die anymore. The side effect is that we can't die anymore in theory, because there's nothing we can hit. We can't even hit the borders. So let's see. I want this like here. See, we go up, and it stops us near the border and just, so the higher we get up, the harder the range here gets, and we still move up very slightly, but the further we go up, the boundary gets tougher and tougher and tougher. But I can still go down. And then I hit the lower border and it says, better slow down, better slow down. You can get closer if you really try, and then in the middle I have free movement, but the closer I get to the border, the harder it is to get off screen. And you could argue, is that good game design? Probably not, but it worked. So we have this auto on-screen staying fish now, which should behave roughly like the original. I mean, we can't die anymore, which is a bit stupid. So I'm gonna hook up a kill key. So we're gonna kill some fish, right? So go to state, respawn, turn up, kill. And kill basically is this here, right? It just says go to state dying, but we don't want to externalize the dying. So what I will say is our book, our window update context has this was key pressed, right? So in the game, in the update, I say basically if the player is alive, if book was key pressed, K for kill as U8, then we just say p.kill. And all of this is temporary logic, and I actually gonna remove the debug noise here, because it will be very hard to debug what is coming if the fish can't die. No fish can die. The return of the magic ghost fish. Sorry. No land for old fish. So we can still do this, and now I press K and the fish dies. And the fish is dying too slow, I know. So let's also port over that logic, and that will need some serious cleanups at some. I want to leave them in for one commit for reference. So if the fish is dying, basically all this logic is so the end case is kind of okay, right? I mean, basically we said if it's 5 seconds, but I don't care. So basically we says if we're dying, that is our logic, right? That's our movement logic. So, and right now we just copy it over. So we need the time since kill. I mean, I'm not even sure why Cocos is still in there, because there was never a version of fish done in Cocos. Weird. So we need a time since kill, and that time since kill is probably set to 0 when we kill, right? When we kill. So we need a time since dying. Well, basically we could say our dying state has an F32 in it, right? So when we go to state dying, go to state dying. My problem is, well, we could just say, okay, we go to state dying with a kill time of 0, right? No, I'm not gonna do that. It's time since kill. So we have a time since dying. Technically it's starting to die, and that is time since dying is actually F32 max. And then if we go to state, this here decides what we do, right? That's why I didn't want to have it in the enum, because then the caller needs to know self time since dying is, well, you go to the state now, so you die now, my friend, and that means right now we could kill. So let's make sure kill only works if self is alive, right? So if we're already dead, don't even bother. Just kill us from from a life state. But that means we have the update swimming, and we have the update dying, right? So in the update dying, we say, let's not move up. So we say self dot time since dying plus equals u times the SF32, right? And we say let y equals self dot pos dot y. We say y plus equals 1.5 times 128 times self dot time since dying times, let's call this TS, right? So let's say let TS equal this back here. So what this basically does, it says the longer the time since dying, the faster we move up, and then some magic formula, and then we just say I mean, we could just say self.pos.y plus equals this, right? No assignment needed. And the angle we approach is 90, right? So we need something that approaches an angle, and we have the problem is with angles, we don't know where we're coming from, right? We can't say do negative. Well, in this case, we could say just subtract, but the approach angle takes the shortest path, right? So that's a helper that takes the shortest path, because if you imagine this is our minus 90, and if we're currently here and then turn up, that's fine. But if we're actually here, if we subtract, we would do a full like 360 instead of just saying, oh, I'm almost there. So this approach angle helper is actually nice. And I'm wondering if it's worth. I mean, the angle mod also is nice because the angle mod gets the angle into range. So this clips the angle. So basically it maps the angle to a range of 16-bit. And I think that came from an old Game Boy game I did. And then it just clips the range to 360 basically, right? So it maps to 360 by the division. And we probably don't need that. This is just a modulo, right? So that means I could give it a 720 and it will tell me, yeah, 720 is nice, you wanted a 360. Or actually, 360 is nice, you wanted a 0, right? Because they basically are the same. So it maps it in the range of 0 to 360. And it would map the minus 90 to a 270, because there's no negative values. And then it would. So actually, I mean, in our case, we could just do the minus because we always want the fish to turn this way. So probably we can get away without this in our case. So what we can say is self.angle minus equals 90. Mm -mm, mm -mm. Well, we could just say minus equals 60.f 60 times ts, and say if self.angle is smaller than minus 90, self.angle equals minus 90. We just clamp it, right? We could just do the clamp, actually. We could just do self.angle equals self.angle dot max minus 90, right? That would say that would be the same like this for the we always return counterclockwise case, right? There's reasons why you don't want negative angles, but for now this is good enough. And maybe we write an angle helper crate for this. Or maybe at least a mass helper, but then I want to write tests and writing some tests. Do you want to write some tests? So the swimming works, let's do the kill. So it does get faster and it respawns. I mean, we don't see the rotation, so that's a bit sad. We could just print the rotation. Actually, we still have the almost the correct code here, so we could just do this, this, and remove these two. Probably the angle would have been enough. All I want to see is that it approaches minus 90. Hey, didn't see you coming. How are you doing? I still want the camera here and not here. So I kill myself and it goes towards minus 90 and then stops. So that should be this. Like it should go like, whoa. And the approach angle might have been the better way. So this works in this case, but is a bad idea in general. Use angle helpers instead once we created them. And actually I'm going to put that into do and say future, maybe out of scope. Let's see if we hit that again. Add angle helpers. So that's the player. So we have the same dying behavior now. We need to do the rotation, right? We need to rotate. And that's actually not too hard, right? I mean, all we have to do is, what if? I mean, here we render a textured quad, right? So what if we had with rotation and just could say, hey, self.angle. What if we had that? So let's go to the renderer and I mean, all this does is, let's copy this for the moment and we will optimize the renderer. So with rotation, right? And then we get an angle f32. Well, probably we don't need to pass the float by reference. So that's the abstraction, right? The renderer doesn't do the right thing yet. Come on. I mean, basically the textured quad is a optimized version of rotate by 0. So we can reuse that code. Oh, still no rotation, right? But all we do is, so this here, right? is add vertex. This basically gets a vector too, right? What if add vertex actually, so what if add vertex, this gets a vector too anyway, right? So let's change this to actually get the position here, right? Let's say this is a vector 2. That's easy, right? But it will help us in a second. So this is just pos, right? Done. We just broke everything, right? So basically this means, and I'm gonna extract that. So let's say we have a let top left, right? Top left equals vector 2 new and then this, right? It will become clear in a second. So this is just TL, right? And I paste this in here and it actually will make the code more readable. And I'm gonna copy this 4 times. So this top left, bottom left, bottom right, and top right, and then it's just like here. So it's minus, minus, plus, plus, and the middle two here are minus and minus, and here we just do the bottom left, and then we can even remove the comments, which is nice. Bottom right, and the top right, right? TR, and then these comments here are a bit moot. We could probably call this VTL, but let's keep it like this. And actually, the rendered texture quad, I'm gonna copy this as well. Let's format this a bit better. I'm gonna copy this, and all I have to do now is interleave the texture coordinates, right? So I put this here, this here, this here, and this here. There is system to the madness. So that's the same, and basically the with rotation, we haven't done anything to it yet. So let's just do this. All right, so let's do this. This is already much more readable. And basically, if I run this now, I shouldn't have changed anything. I just changed the signature. I wonder if I use that somewhere else. Oh, add vertex. Add vertex has a vector 2. Yeah, not a vector. And did we forget all the semicolons here? Yes, we did. Thank God for column-based editing. So that's better. Sometimes it's nice to use the mouse for this stuff. So this is now you say, why do you do this? I mean, so now I want to rotate, right? And we know that the position is our center. So what do I do for a rotation? I mean, all I need to do is have a rotation matrix, right? So this is a 3-2 vector. So if let's so let's say add textured quad, and that actually has a rotation, yes. So we're getting a vector 2, right? And that does start end instead of center, but we have our 4 vectors here, and then we have a 3-3 matrix, And all we do is we multiply our vectors by the 3, 3, right? So all we need to do is 3, 3 matrix with a z rotation. So that's easy, right? So all we do here is we say, okay, and we don't have that, right? So let matrix equal matrix 3, 3, and we don't need a 4, 4, we need a 3, 3. Z rotation, right? And that's just getting the angle. So that's one step, right? So we need to go and create a matrix 3, 3, and I don't think we have one, so let's create one. So touch source, we need mass anyway, so, and that has a matrix 4, 4, which is a bit useless to us, so let's go into Mars and hook up the matrix 3, 3. And funnily enough, at one point I had used matrix 3, 3 for forever and realized I had stopped out one of the multiplications. So let's open matrix 4, 4 here, and basically matrix 3, 3 here. And what we did here, a matrix was made up of 3 vectors. I don't think that's a good idea. So we'll just use this, even if it's a bit uglier to read, because then for the implementation, this is actually quite easy to read, because you just use maybe we use vector 3. Do we? I mean, it's much easier to read than the indexed based, and we never pass a 3, 3 matrix. Interesting. Let's do it like this. Let's use a 3, 3 vector, and that means we need a 3, 3 vector. Well, we need a 3 vector, but that's totally cool. So let's have a vector 3. We need that anyway at some point. Hey Reed, how are you doing? We're creating lots of basic, well, actually we copy the vector, right? We're creating lots of basic infrastructure code again, but we almost have gameplay. We have something that I would say is kind of gameplay. And now we're rewriting all the mass stuff from scratch. I know there's libraries for that, but I don't want to. So that's our vector 3, right? And then in our matrix 3, 3, we use create mass vector 3. So we have a let's hold the derives for later. So we have a struct matrix 3, 3, and that's made out of 3 vectors, right? 3 vector 3s. So that is a valid 3, 3 matrix, and we can just address the parts by. And what we need right now is, all we need actually is to make z rotate. So the z rotation with the angle, just call it A, that returns a self, and that's a self, and we'll do that in a second. Now it gets a bit ugly, because this is now x is vector 3. Not sure, maybe we should have a from something. So that's our z rotation, and I'm just gonna cheat. We could look that up, but basically z rotation is just, it's just c minus c. So So we just need the sinus and cosine. So let's say let sinus equals a dot sinus, and let c equal a dot cosine, and then it's basically it's the c minus s s c and then the 1 in the bottom, so it's c minus s0, and then it's I never can remember the order, it's sc, which makes sense if you deduce it, but that's not this kind of stream. We're not going to we could just look it up in a math book, right? So this is a rotation matrix around Z. Did we actually implement that new for vector? Yes. And then obviously we also need the multiplication with a vector 3, right? So, and that results in a vector 3. So I wonder, we don't do that in place in Rust, right? So we have a function mul vector 3, and no, not gonna say it, not gonna say it. So we multiply ourselves with the vector 3, right? Reference. And the result is vector 3. And this is now pure basic matrix multiplication. So we store this in a helper. Yeah, let's do this. I mean, in the original D, we did this because we were overwriting it. So basically we say let x equals v dot x, let y equal v dot y, let z equal v dot z. I mean, in theory, the compiler shouldn't care. And then what we will return is a vector 3 new, and I'm gonna do this row-wise. So it's basically, it's so it's self.x.x times times x. What something is, oh yeah, it was sx here, that's fine. So plus our, so self.y.x times y plus self.z.x times z, and then we just go through, we do that 3 times. That's just vector multiplication, right? So this is yz, so multiply xyz with x, then multiply xyz with y, and then multiply xyz with z, and add them all together, and that's basically our our vector multiplication. I hope I didn't do a stupid typo now. Shall we? We really need tests. We'll just go like boo 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 boo. And we just matrix 330 rotation. Oh, yeah, the renderer used that already, so maybe just say matrix 33. And this could be optimized. We could use streaming to parallelize the adds and multiplies, but performance is the least of our worries in this game. So that worked. And now back to the renderer. I mean, all we need to do now is we have the matrix, and all we need to say is let TL equals mtx mul vector 3 TL, right? Yes, this could be a loop. This should be a loop. This might be a loop, and then it's just 4 times the same because we do this, and we do this, and then we do this. So it's just very verbose, but so we're rotating the vectors before we hand them to the material. So it's not the GPU doing the rotation, we do the rotation, so we shouldn't just tell the GPU, just render. Oh, it's a vector 3. That's actually interesting. So do we need, actually, why have we been, I mean, we do have a matrix 2-2. So probably a matrix 2-2 with a vector 2 would have been enough. I mean, shall we just do that again? We can use the other one anyway. Yeah, let's do that. So touch vector 2, which we already have. So let's do a matrix 2-2. Hook that up. Yeah, print again. All those wasted paper. Hook that up in mass. I mean, maybe we should switch to vector 3 anyway, everywhere. Not now. Not now. Not now. But it might be a good idea. Even if it's just two-dimensional, that third parameter might come in handy. So I'm just going to copy the matrix 3-3 because the matrix 2-2 is literally, I mean, it's, the difference is this here. It's a 2 vector. All of this could be templated. This is basically the matrix multiplication is just leaving out this step here, because for a 2-dimensional rotation we don't need 3 dimensions. This is just, so all the functions are very self-similar. And then the matrix multiplication is basically the same, we just leave off the z component. So this is basically this and this and this and this and this. So we just cut off the extra dimension, right? Now this should be good. So in the renderer we can actually use it 2-2 here and actually use 2-2-2. And this will come on super handy when we get to the texturing stuff, because we'll use some of that matrix stuff there. Well then, what did I? Matrix 2-2. Yes, thank you, Rust. So we actually need a 2-2 here, not a 3-3. And we probably can use a 4-3 and 3-2. So this is, shall we just see what happens if we run this? I'm still typing run every time. I could just get away with R. Let's stop this. Sorry about this. Back in a sec. Sorry about that again. So I stopped this. I didn't want it running without me being here and it eating my hard disk alive. So does the fish rotate? Oh, it doesn't render at all anymore. So what did we do? So let's debug mtx and TL, and actually for the matrix 2, I'm gonna go into the matrix 4 and gonna steal the formatting here. Probably should do the same for matrix 3 because we'll need it anyway, but I mean, it's just 2 of these, then another 2 of these, and then that's it, and it's actually self dot x dot x, it's self dot x dot y, it's self dot y dot x, and self dot y dot y. And yeah, stealing it was not really worth it, but and then we have a vector 2. You could have just formatted the vector 2 probably. Yeah, I wanted to copy it all. Thank you. And this is just these 2, right? So that's just these 2 minus these. So what's wrong with our matrix? Our matrix is just broken. I mean, we could use an identity matrix to verify. Matrix not found in scope. Oh, because it's vector 2. So what we will do is we will definitely have a pub function identity, right? And that's just a self. Let's steal this because it's close enough. Oh, close enough. So this is 1.0, this is 0.0, this is 1.0. So identity is always needed, right? So where did I go wrong? Oh, debug for vector 2. Yeah, fine. Speed mode again, running out of time mode again. Nah, we still have time. We can do the rotation and we can start with the animation, I hope. Animated fish. So the matrix. So the matrix looks okay, but just to be sure, I mean, if we say let mtx equals matrix 2 to identity, right? Oh, here's our problem. Copy and paste. So if we have an identity matrix, then we just have the unrotated version, right? So if we see a fish now, it was actually the typo. So matrix looks kind of okay-ish, mostly, at first glance, maybe. So this looks okay. So it was actually the TL being splattered here was bad. So let's use the actual rotation matrix and see if we put the rotated vectors into the buffer. Okay, we get an unrotated fish. Whoa! Whoa! Oh! We rotate around 0. Oh, we need to. Okay, basically what we need to add the position later, right? So basically, if we would do this, we remove the translation part. That means all rotated quads are rendered at the center now, but and then we can add it later. So there are two ways of doing that, and we're gonna do both. So Fiish is rotating. We have one problem now, why it's rotating so fast. So basically, this rotation here, this is angle in degrees. Is it? This is actually the angle in degrees, while our matrix here, this is radians, right? So I wonder why this worked in the old version. Makes the rotation. Oh, we had a... No. This is just... So... No, this is the wrong one, actually. So let's... So... Game object render... Okay, so this does a degree to radiant, right? So what do we want for our renderer? I think degrees are actually much nicer to handle for the user, but I mean, in the end, it's just a multiplication, right? It's just this. So if we just went into our renderer and said, yeah, I hear you, but let angle equals angle times this, right? This is just pi over 360. So 3.14 divided by 360 is it's 2 pi. It's 2 pi over 360. So it's 2 times pi over 360, right? Let's just, I just used the more precise value for pi when doing this number. So this is 2. So we could do this. It's a decision. Do we want angles, degrees or radians in our interface? Well, Fiish should turn from minus 45 to plus 35 to minus 35 right now, right? The offset problem I still have on my radar. So it turns down and now we dampen at the bottom and now it turns up and it dampens at the top, right? So that feels right. Obviously we ignore the position now. And there are two ways of fixing that. I mean, A is we could just say, okay, for every vector, we basically say add pos, right? We could just do this. Let's actually just do this. We just add the position afterwards instead of before the rotation, because that changes the pivot point, and that means vector needs a add, but that's fine. I mean, pub function add self, and that just returns a self, and that just returns a self, where x is, oh, maybe we need the other vector 2 here. If we need to add 2, we need 2. So this is basically self.x plus other.x, right? And this is self.y plus other.y. We could just do that. And that feels wrong. But we'll keep it like that for now, and there's a reason to it. I'm going to tell you how you could do it. So now the fish is moving correctly, right? Bottom, top. It looks a bit weird because the initial position is in the downward tilted position. Maybe let's fix that real quick and say open fish data. Open that in gallery mode, cause so you see the initial fish face is facing down and not centered, so we probably should use fish 21. Maybe use fish 21. So in game, we want fish 21, we said, right? We need to load them anyway, all of them anyway at some point, and then in player, we also use fish 21 instead. Well, that should help with the visual reference. It's not really, it doesn't really matter, because it will be animated soonish anyway. So now we have rotated quads. In a slide, so that's better, right? Because the animation phase is not, the original was like down, and this is more like neutral. So that helps to understand the, and then it bounces off the border. We have rotating fish. I mean, the thing here is that I don't like, and we're gonna fix that, but we're gonna do so this add here, I mean, we do the addition for 4 vectors. We could just say let mtx translation t tr equals matrix 2 to translation, right? And could just say pos.x and pos.y, and then we say let mtx, so let's say mtxr is, this is mtxr mul matrix mtx tr, right? Oh, and then we just, we could do that, or we could just do it like that. All right, so we create a translation matrix, multiply that on top, and then we can get rid of the add here, which is probably cheaper to multiply the 2 matrices once than to do the manual add, but that is for to do future optimization once we have full matrix implementation. And I don't want to do the full matrix implementation right now. And I mean, this is 4 ads, so please. That's 8 ads and a copy, so and it's gonna be fast enough. Booger. It's at the point where it's so much fun to play with it. One more thing. One more thing. So technically, in the Fiiish app, in the stuff we're gonna delete. So what we do here in the render, I mean this strange positioning. I mean, technically, all we do is so. How do I put this? No, that's I was talking about this loop. So we use T as an angle, right? So T is as an angle, right? So if we just set T dot cosine here, for example, to make that a bit clearer. Fun till the day is over again. I need to stop singing. So, but if T is an angle here, right? Why don't we say render text just quad with rotation and just say, okay, T, and T is in radians, so I need oh, that's where the 57 point something came from. Interesting. We hit that earlier and didn't remember where that factor came from. So that now means I probably am off by 90 degrees of what I actually want to do. So all the fish should be rotating now. All the fish are rotating now in the wrong direction. So I need a negative in front of here. And they will still be off by 90 degrees, I think. Maybe. Let's see. I mean, it looked funny what they did. So what if I subtracted 90 degrees? I'll actually gonna plus 270 because I like that more. Yeah, now they're overlapping too much. So what if the actual scale, so the let D equal T dot sinus. So this gives us a value. What if we set d times this? And t is bad because t is having too much fun with the fish. I knew this would happen. Yeah, so the value is it's showing a little bit, but we need the value to be bigger, so I want to make this 0.5 times and then 0.5 plus, right? So we get only positive values. It should spread them out a bit more. This is all just playing with math, so this is not what I expected. I mean, this looks cool, but this is not what I wanted. This is not what I... Stop it! It's just showing the flexibility of the framework we're building. And please don't call it engine. It's not an engine, it's a framework. Yeah, maybe that was a bit much, but that's roughly what I wanted. So let's say 1. We need sliders for these fun values, right? So you can just move a slider and see live what's happening. Yeah, no. No, 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 no. Not now. Not now. Not now. He can do gazillions of things with these fish now, but I want to make them swim. And we can still kill the fish and it will turn up and go straight up before it dies and then it respawns. So actually that's what we wanted to check, if our dying angle works, but it does work. Nice. So let's clean this up a bit, shall we? So in the player we have some debug, which is a bit noisy. We're gonna leave this in for reference. We're gonna leave this in for reference. Oh, we can remove these two, right? And this should never trigger, but better be safe. So, what did we do? Allow quads to be rotated, add fish rotation and use direction for movement. Done. And rotated quads give us so much fun. Also, we added some more matrix functionality, but I'm not gonna add this here. So, what did we do? Allow quads to be rotated. Render fish with correct rotation. implement fish behavior from v dot to x. Right, that's the dying stuff and the angle stuff, the limiter. That's all that. We leave the code in for reference. Have some more fun with the fish. I don't care. We use a different texture. Okay. We start to add matrix 2 2, matrix 3 3, and vector 3. Work in progress, incomplete, and untested. So stage this. This is the vector 2 that just has a add and a debug. This is the renderer that uses a vector now instead of individual values and allows for the rotation. Yep, we have the matrix 2 2. We have the matrix 3 3. All of this incomplete, and we have the vector 3. Commit, rebase, push. Just in time. Just in time, only 5 hours in, and I'm supposed to, well, I aim to stay below 6 hours right now, so do I enjoy the sunshine now and continue for an hour later, or do I continue now and don't enjoy the sunshine? Let's do that animated texture stuff, right? So what is an animated texture? So technically it's not even part of the renderer, but I will add it there anyway. I mean, what's an animation, right? All we say is, if I go into the player, for example, if I just changed this number every frame, I would have an animation, right? So that would be one part, and the other part would be a load them all. Right, if I loaded fish swim 0 to, let me check, fish data, fish swim star. If I loaded 0 to 26 and just replayed them forever, I probably would. So we could just put them all manually here, right? We could just do like this. But I'd rather have a helper for that, so I mean, they come from the atlas anyway, but let's say touch source renderer animated texture, right? And this is just a helper for now. So what if we have a renderer and have the animated texture down here? Well, actually we have it up here. Animated texture. And I'm gonna fix this in a sec. Right, so what if we had the animated texture actually, and that's pub struct animated texture, right? And then we have an implementation, animated texture, and let's just make a helper. So if we go to game, right? All we want to say is, hey, what if we had a helper that said, can you just register them all? Just wreck them all? right? So just this is your template, and now just find them all. Hmm. Hmm. How do you do this in Rust? So what if you could just say animated texture register all? We pass in the system, we pass in the renderer, and we pass in fish swim %d %0040, right? That's what I would like. That is what I would like. So I say just load them all, and actually that's what we will do. So animated texture. What if I have function register all, and that's a standalone, and that gets a system reference, the autocompletion, that it gets the renderer because it needs the renderer, and it gets the template, right? Which is a string. And maybe it returns how many it actually got, right? So use size 0. Let's close a few of these for faster access. We are clicking. So now we're in the game. So this works, right? So we need to use the animated texture here. So all it would need to do, basically it would do this, right? It could be a bit smarter. So it could say, so one part would be doing this, right? And the other part would be let name equal, I don't know, something. Get the name somehow, right? And then it says let mutable fs is system get default file system, and then it says if fs exists name, do something, and else we're done, right? So the first name that doesn't exist, it just returns the count, right? So what if we had something like let mute I equals 0, and then we do a loop, and then we say this, and basically here we say I plus equals 1, right? So as long as the name exists, do something with it, else stop doing it, right? So how, I mean, this is basically let name equals format, and here's my problem. I would like the format string to be this template, right? But I don't think Rust will, so I want to do, well, I want to do template I basically, right? And this, I don't think Rust will let me do that. That is a bit sad. I mean, you can do a cargo check. Must be a string literal. So how do I do this? Rust format string with template. can just use string replace. I don't want to update it 3 years ago. I mean, so I don't want to go there, so I'm gonna change the interface here. So it will get a prefix number of digits, right? And this must be 1, 2, 3, or 4, right? So we call it, this is a hack, but basically we don't call it like this. We call it like, and you get 4 digits, right? And then we say, okay, and then this makes me sad that that doesn't work. So we say, let name equal match number of digits. If it's 1, well, right now we just support 4, right? Just let's do 1 implementation. Then we basically do format, prefix, postfix. I have to look up how to do the formatting there. Prefix I, right? And this is borrowed. And all the other cases are basically to do, add support for digits. Right? And in this case, it basically returns I. And in this case, this is a to-do, right? And this here doesn't need to be, I still need to figure out Rust format. I'm pretty sure there's a way to say 4 digits, right? Can I get some kind of... Okay, so it's :0 :04. That's... I probably write a string replacer for that, but... Oh. This is unreachable. Yep, I know. But basically, this is our to-do case, right? So renderer, register, texture, create system, and this is basically name, right? So start at 0 as long as we find something that starts with the prefix. And yeah. What? Texture not found. Okay, fair enough. Use create renderer texture, right? And renderer probably too, so let's go to... This is just a clutch. This is just a, I mean, ideally we have a config file that just says, hey, by the way, here are all your textures. Animated texture line 25, so yep. That needs to be done. And that name was empty because I didn't have the semicolon. We still don't have protection against duplicate loading, so why? System not found. Okay. Okay, use create. So today, as soon as animated textures are animating correctly, we're gonna stop. We're gonna stop. So fx's name found nothing. Why is this nothing? Why is... Oh, because we implicit returns are by the devil, and lack of ternary operators is even worse. Wait, did we... This is interesting. Layered file system doesn't implement exists. So basically this will always return false, right? So the layered file system needs to implement exists, and basically it's if exists, return true, otherwise false, right? So check all the file systems, and actually we don't need to reverse it, but it's just for... okay. Well, this would have said 0. Nope, not with me. Almost. We're racing the clock again. I love racing the clock. Immutable borrow, address to texture create. Can't borrow system at mutable more. Really? Ah! Okay, we cheat. Let toLoad equals back new, right? So let's have two loops. So in the first loop, we just say if it exists, we say toLoad push name, right? That's all. We don't even, and in this case, we just break. We pull this out. We don't even need to count. Well, we need to count. So we say if the file exists, we remember the name for later, right? And then we say for n in to load. I'll probably call this name. And then we just return to load length, right? I mean, it might still fail, so we might need better counting, but you get the default file system. We have a list of names to load. We check until we fail. And actually, this gives us a nice debug point, because this will tell us, hey, I found these. It might still say I couldn't load these, but this is a workaround till we have configuration file handling, right? So cannot borrow as mutable, that's correct. If we want to push to it, we have to make it mutable. Speed mode enabled. Oh. So this is just a workaround for we don't have config file handling yet. But I mean, might be nice during development where you don't know what your artists will provide, where you just don't know what you have. So basically, somewhere here, I mean, we have far too much debug noise. Loading fish die, fish swim 0. Are we actually... Okay. Let's actually do it to do die here. To do roll the dice. Dice, dice, lady. What am I overlooking? Going too fast, I know. So to load is empty here, so why? Maybe our name is mangled somehow. Fish swim 000 does not exist. Why not? Why not? Because oh, come on, really? So the name is Fish Swim. Oh. 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 It's a PNG. It's the PNG, so technically we want to find a file. Ah. We could just do PNG and be done with it. I mean, we don't have anything else in a game ever anyway. This is a development helper for now. So this now loads fish 0 till fish 26, so all of them. Hack to work around missing exists dots with dot star, right? And this probably should have loaded all of them now, so we just test a random one in the player in a second. Let's just check if we can use, and player can use the 26, right? If we use one that's invalid, we get the default one. So let's check if 26. This should be coming from a configuration file in some form. So this scanning the file system for all of them is a horrible, 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 horrible hack. Don't do that. Okay, fish swim 26 not found. But didn't we say we loaded it? Hmm. So texture needs to shout when the create is failing, right? So the load can fail, right? So the load returns a bool when it can't find it, right? Yeah, this should. So in this case, if not tloads print line warning failed loading texture name. I mean, we don't stop. It's okay to continue. And that way you can work even if you don't have the assets yet. But we should at least mention that it's failed, right? Warning, failed loading, but why? We know that we loaded fish swim 0 successfully, right? And we loaded 21. So what could, so F is invalid, right? Oh, because let name axt name axt equal format dot png, and this is just the name, and this is with extension, and we push the and we could loop. Thanks for the follow, Bivria. How do you pronounce that? I need some Bavaria, Bria. Sorry, I struggle with consonants in order. So okay, so now the loading does not fail anymore. It was just this. So hack this info, hack scanning the file system is a bad idea. The info should come from the config. Burial. Oh, it looks like a V. How are you doing? We are hacking animated textures into Fiiish. So what is Fiiish? Fiiish is a 10-year-old game that I worked on various platforms and a bit here and there. And I'm currently porting that to Rust from scratch with all the rendering and logic management. Let this compile. Okay, so yeah, I have 5 minutes. So this is the C++ version that runs on various different devices, and this is just the Apple devices. So tvOS, macOS, iOS. Come on, where is my simulator when I need it? And so this has a metal rendering backend and OpenGLES and OpenGL and Vulkan, and it had a DirectX backend at some point. So this is my test bed of testing stuff. It was written over a weekend like 10, 11 years ago for Game Jam. And then I started to extend it and extend it and extend it and forever work on it. And now that it's done, well, mostly, I'm starting to do it in Rust. So it's basically an endless swimmer. You press a button, the fish goes down. You let go of the button, the fish goes up. You collect coins. And if you hit anything, like this rock here, you die and start over. But it's a nice test bed because it has rendering, it has input, it has joypad support, it has UI system, font rendering, keyboard navigation for the UI or just click navigation. If you look closely at the background here, actually there's some nice shader tricks going on to make it fade dark and light. If you see that, and then when you hit something, it goes into black. So that's nice. It has animated textures for the rotating coins and actually a fish, so it doesn't look that boring. It has a UI system that works. Audio isn't currently routed through my capturing, but that works. So yeah, and that's what we're doing right now. So we're hacking in the animated textures, which is a bit hard because we don't have a texture atlas system yet. Normally you would load the atlas and then all the animated textures would be in there and you would just load one big atlas. So for example, let's say open slash data work omnimat fish data game atlas png. This this is the wrong window. So you just load this and then all the textures would be automatically be loaded and in there, but we don't have that system yet. So we cheat a bit and just load everything that's on the file system and don't do this. But the nice thing is now we can, did I press save? Yes, so now we can use all the animation frames and all we have to do is now just cycle them. So, and that's the real meat to this thing, right? So what if I had a pop function new the usual self dance, and I'm on the clock. I only have half an hour left, but I think we can do that today. So what do I want from the player, right? The player wants to have an animated texture, right? So I want to have a animated texture, right? Which is an animated texture, and then animated texture new. And then basically what I want to do is an update. In my update, actually that's interesting. Actually, that's interesting. So if I'm in the swimming mode, right? If I'm in swimming, I want to do self animated texture for swimming. Let's ignore states for now. Update, right? And all that gets is a time step. That's just a helper class, so it doesn't need everything. So what I need is a pop fn update mutable self with a time step, right? That just updates the animation phase. And then what I could do is give me the name of the texture I should use now, right? So, or I or in the render here, basically here we would say, just thinking out loud, basically I would say self animated texture use, right? Use. And then I pass in the renderer. Alright, so this would basically be a pop function r use mutable self. Doesn't even need to be mutable, right? And here I would just say renderer, use the correct part of it, right? So this is, and then I need to set up this thing somehow in the setup. So in the setup, I would say self.animatedTexture.setup prefix. So it's fish swim, right? Number of digits. Yes, I know. And the speed, right? So let's say 25 frames per second. Alright, let's stop this out a little bit. So let's say pop function setup mutable self gets the prefix, and all of this is a hack. Number of digits, which is a U size, and FPS, which is a F32, right? So as a user, we just say we have an animated texture, we set that up because we know how it's formatted. We make sure it gets updated in the update cycle where needed, and then when we want to render, we just say, yep, render it, right? So interface is stopped. It should have some behavior. Animated texture doesn't implement debug. Yeah, okay. Oh, come on. So basically, it's not an animated texture. It's a player to find the current texture for this animated texture, and this should be loaded from a file with the, do I bounce, do I ease in out, what's the speed, do I have repeated frames, maybe I have it backward. So this uses frame 26 right now, right? So what I need the prefix. Basically I need all of these, right? I need this prefix, I need the number of digits, and I need the FPS, right? So in the new, I set the prefix to string new. I set the number of digits, and I hate this hack, and the FPS to basically don't animate, right? Then in the setup, I just say self prefix is prefix to owned. Self.number of digits is number of digits, and self.fps is fps. Then I obviously need a current frame, right? And I'm not going to do the timing, I'm just going to animate one frame at a time for now. So that's, I don't know, U16 is probably plenty. So the current frame is 0. And when I update, all I'm going to do for now is self.currentFrame. There needs to be some timing logic based on the frames per second, but basically, okay, right now we don't know when we are done. So what we also, number of digits, number, the frame count, right? Number of frames. Is also well, it's U16, right? So number of frames is 0. This will also get number of frames. Thank you for not doing what I wanted. I'm too lazy to type, so I'm just clicking a bit. And then the caller needs to know, okay, number of frames is, where's the setup? Where is the setup? So I know it has 20 sides. I want to use 27 frames. Probably it should also have a start frame. Maybe it sets the end frame and the start frame instead. Maybe not. So if self.current, well, basically let's self.current, no, we want to wrap around. So if self.currentFrame, we could just say this is self.currentFrame plus 1% self.frameCount, right? Number of frames. When it wraps around, we just start again. And here we do the, maybe we extract this functionality, right? So what do we call it? Append number with digits. So we have a prefix, right, which is a string. We have a number. Oh, we have a number which is, what is it? It's a U16, and we have a digits, which is I don't care actually. Its U size is probably a bit crazy, so let's make that a U8. And that gives me a string, right? Right. So basically we have this, but we do return this, and I'm not sure why the formatting broke, so now let's actually do it. So this is extracting it. We have the prefix. So down here we can just say append with number of digits, and that is prefix number of digits and the actual number. So it's I, right? Because we need this function in 2 places. So Yeah, and actually this hack now goes here. Right, and then we can use the same up here and just say, basically it's the same line of code. This is the same line of code, and then we just say name, right? Pretty sure I messed up something. That was too much in one go. Whoa, 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 what did I... The size of cannot be known. Okay, so this gives us a reference, but we need the owned version, so we need to make this owned. And I think all the other... Whoa, what the... what? So, I'm pretty sure, so... Cannot find function, okay. Because this is actually... animated texture colon, right? And I think all the follow-up is just fallout from that. Fully qualifying local helpers is, I am not a fan of that. Okay, and now number of digits, prefix, self.prefix, yes, I did mean that. This is self.currentFrame. And this is self.number of digits. That's half of the fixes. We're getting close. We're getting close in time again, as usual. But daily goals are daily goals. I want to refund. Not found in scope. So in line 49, it doesn't find the I, which is correct because we said this is number. This is number. And then there's a... we need to borrow in line 42, which is correct. So this is a borrow. And then found U size. So number of digits should be U8, right? And that's probably here as well. And I probably forgot it in 8 other places. Come on. Expected to, and then in line 65, yeah, it's the U size thing again. So number of digits is U8. I mean, if you have a number with more than 256 digits, 55 digits, I probably ask you, what's your naming scheme? How many frames does that animation have? So, oh look, the fish is swimming. Obviously it's too fast because it's running with 115 frames per second now. But it's swimming, so we know the frame rate, right? We know that frame rate and we know the time in the current frame. So from the frame rate, time per frame, right, is an F32. Time in current frame is also an F32, right? So time per frame is just, I probably say don't animate, so go forever. And time in current frame is 0.0. So when I set it up, I probably, the FPS and the time per frame is basically the same thing. So time per frame equals 1 over FPS, right? And then the self time in current frame, well, it's 0 anyway, we don't need it. So instead of this, we say self dot time in current frame plus equals time step as f32, and then say if self dot, well, actually while we might have skipped a few frames, right? So while self dot time in current frame is larger than self time per frame, right? So if we have 1 second per frame and we waited for more than 1 second, we say we increase by 1, and we do time minus equals self dot time per frame, right? So if we were paused 5 seconds, we just jump 5 ahead. Is that all? Is that all already? Was that too easy? Is there something fishy? Tomorrow we will have to decide if we want to do the UI system or the collision detection. So this frame rate, I mean, it's hard to see, but if you compare with this version up here, it feels like it's the same, right? And we can run a debug, which will run at a much lower frame rate. Well, probably not, because even the debug version is fast enough. Come on. Too much debug output. So even here it runs, right? It's still 73 FPS, but if I add more noise to render, I wish I still had the times 100 in there, because this will take forever. So let's do that. It's here, right? Let's just add 1000 per click again and see how it comes to a crawl. Is the rotation of the fish correct? Okay, so we have a swimming fish, and maybe it should be swimming in the waiting for start already. So let's make this much slower. Can see it drop below 60 FPS because I'm drawing like 10,000 triangles now. So it skips animation frames, but it still has the right speed. So it's like a camera with a very slow shutter speed. But even if the frame rate drops, the animation stays stable. It just skips, and that's what we want, right? I mean, it's literally down to 20 FPS now, so it skips, but it still works. And that's what we want. So nice. So I'm gonna undo this. Gonna run release. And we have an animated fish. I want to animate the fish in the ready state as well. And we add the dying animation too, right? I think the die only has 2 frames. So let's do the game. Yeah, and technically we multi-load so let's do the die, and it has 2 digits, and 2 digits is not currently supported, so let's add support for 2 digits. It's a hack. It's an ugly hack, and I don't want to do this, but let's do this. So we're loading the reload, and we have dozens of materials now because we have dozens of hardware thingies. So what we could do now is animate the texture dying. Alright, dying. And this could probably be handled a bit better, but right now we're proving. So this is dying, and this is die. Actually, fish, data, fish, die. How many frames are there? They're just 2 frames. I mean, are they even different? So this is a dying animation, and I don't see any animation there. So yeah, well done, Kevin. So let's say we have 2 frames here, and that has 2, but let's just put it in, because so if we're swimming, we do this. If we're dying, we do this. And then in the rendering, basically we say, oh, instead of this, we do this, and this is dying. And actually, so one more thing, we have the update swimming, and we have the swimming. Let's have the waiting for start. Waiting for start. Let's actually implement that real quick, and that's just basically these 2 lines, right? Because we don't do anything here. So this is close call. I still have to clean up this mess. Oh, what did I do? Metro, I'm starting here. Line 236. There needs to be comma here, because I removed the braces. So now the fish is swimming when it's at a standstill and just continues the animation. And if I press K for kill, it's playing the animation that is no animation, right? And then it respawns when it goes out of frame. Yeah, maybe the transition between swimming and dying could be a bit nicer, but I think it's good enough. Fiiish, let's clean this up. So we have animated texture, a bit hacky. And tomorrow we'll probably do the texture atlas stuff, because right now we have gazillions of materials. I mean, right now you see we have dozens of materials, and only because the hardware ID of the texture is different. So this is, and if they are in an atlas, the hardware ID is identical, so it will be one render batch, and that's what we do want, but not today. So we updated the to-do, right? Yes. We add very hacky initial support for animated texture. And the loading is hacky. The actual player is not too bad. Use animated texture for fish, because everything looks better animated, and this should come from a config file. Hook in. We still double load, but I leave this in for today. Hook this up. Throw an arrow when texture loading fails. Fix the exist check. Yeah, actually fix exists for file system layer. And then we have the actual animated texture, which is a bit hacky, but isn't too bad. Commit, rebase, push. And as always, everything is right here on GitHub, completely public. Dummy data. Actually, do we have everything in? Yeah, the official data is there. So I'm gonna put this into the chat. I am gonna start this once more because I really, really, really start to like this. This is starting to look good. Too good. Too much fun. Too good looking. Too much fun stuff to play with. And then I'm just gonna make this quite big. I'm gonna make myself big. Well, oh, Halo mode. Halo mode. We have animated fish, and with that I say thank you, hit the follow button, see you tomorrow.